Good morning, Jose. Hello.
Good morning, Claudia.
How are you? Nice to.
Fine. So numbers are growing
I can see.
regarding participants. So if fine with you, we can just wait 2 more minutes until 9, and then we can start.
Yes.
So good morning to everybody. So we'll start in just 2 minutes. Let's try to see if we have more persons connected. So it's 9 o'clock. So I think that we can start. Good morning to everybody. My name is Jose Tarazona. I am the chair of the working group on nanotechnologies under the EFSA Scientific Committee. It's a cross-cutting group that covers all the areas of nanotechnology that was supporting the scientific committee in the preparation of the two guidances that will be presented today and tomorrow. After the welcoming speech, I will give you some practicalities, but please remember that this meeting will be recorded and that the recording will be made publicly available because we have received a lot of interest in the meeting, and we thought that it's quite important to have this also for those that are not able to follow the meeting today and tomorrow. As mentioned, I will give some practicalities later on, but first it's my pleasure to introduce Claudia Roncancio, the head of the methodology and scientific support unit. So basically my head. And that she will introduce you and give the welcoming. Claudia, please.
Thanks a lot, Jose, and good morning to all the participants. Well, I'm quite new as head of this unit, so I started on the 1st of January. And we have a unit dealing with scientific support and methodologies. Quite a big unit, 40 people. Jose is part of the team on preparedness, and we have really a pleasure to be all together and with several colleagues. And welcome to all participants, and thanks a lot for your interest and for your positive reply to this invitation. I would like now to start these 2 half-day online workshops. As you know, in the food and feed sector, nanosafety considerations have reached high relevance. 3 main factors can be highlighted on the importance of this area in Europe and worldwide. First of all, nanotechnology is contributing to the technological developments, and it is expected to contribute even more to the farm-to-fork strategy with the safe by design approach. But not only in the farm-to-fork, but also in the chemical strategy for sustainability, where there is some work in progress to provide incentives and to ensure work in this area. There are also continuous scientific developments in the area of nanotoxicology, and these developments increase our capacity for improving EFSA risk assessment of engineered nanomaterials, requiring, of course, regular updates of the guidance. The first scientific guidance document was published in 2011. Then it has been updated in 2018, and last year we have made the revision, or the colleagues have made the revision. Third point is the fact that assessment and enforcement activities have confirmed the presence of a fraction of nanoparticles in several conventional materials. Following a mandate from the European Commission, EFSA has developed a scientific guidance for providing clarity to stakeholders on the information to be submitted. Ensuring the safety of this material is a shared responsibility, where several actors are interacting. Here today we have a unique opportunity around this virtual table to have several stakeholders. On one side, we will have the Commission, we will have EFSA, and we will have all the stakeholders. And we have the opportunity to present the two scientific committee guidance on nano assessments that have been published in August 2021. The aim also is to get feedback from the stakeholders on their implementation. In this particular event, I would like to thank all participants, and several organizations have responded to offer and have offered sharing their experience, their practical experience, and we are going to have several presentations. We will be hearing from the stakeholders, where the presentations will provide details on the challenges, but also on the opportunities related to the implementation of the guidance, and will contribute to the discussions at the level of the working group, at the level of the EFSA Scientific Committee, and EFSA in general. We would like to acknowledge specifically the involvement of these organizations, and I would like to thank the speakers for the today and tomorrow sessions. I can see in the line of participants several known faces, several experts with whom I have been working before, and several people that I met in my previous life in the FIP and the FIT area. Now it's an opportunity that to work together on these guidances, and both guidances are complementary, and in combination they offer science-based high level of protection expected by consumers and the society. But we need to look also for the future, and in the future we are aware that there are constant scientific developments in this area, particularly in the EU, with several large-scale research projects and clusters. Further developments are also expected in the near future. For example, we know that both guidance documents already include several recommendations for minimizing animal testing and maximizing the use of non-animal methods, the so-called NAM, or New Approach Methodologies. The use of these alternative methods for assessing nanomaterials is highly promising, and EFSA will launch a large project in collaboration with the member states during this year. Finally, I would like to express also my gratitude to the members of the Scientific Committee for all the work done on this guidance, revision, adoption of the guidance. Members of the cross-cutting working group on nanotechnology for their work. We have also observers from Commission joining the working group for the contributions in general to the guidance and in particularly to this event. A special mention, of course, to my colleagues in the unit, so Jose, Maria Chiara, Irene, for the scientific support provided, for all the energy behind this event and on the guidance. Organizational support, we got it from Francesco, Maria Simona, and Vanessa. And now with these words, I would give the floor back to you, Jose, to continue with the meeting, and then to our colleagues for continuing with this morning session. Thanks a lot, Jose.
Thank you very much, Claudia, for your welcoming. So as announced, I will move into the practicalities. So let me share my screen. So as you know, we have a program including the presentation of the guidances as well as some experience and lesson learned, both from the members of the cross-cutting working group, but also from external stakeholders that will be very relevant. The guidance has been already several months published and before were applied as drafts. So it was important to get your feedback as well. And you will have also the possibilities for raise issues and technical difficulties and challenges, but also opportunities for the application of this guidance. So it's online, but nevertheless, we want to have a very open discussion. Today, we will cover the guidance on the particle technical requirements that cover all conventional materials are applicable to all chemical substances. So what we expect is to have all the all dosage on chemicals that are submitted to EFSA that apply this guidance to clarify that there is no need to have a specific assessment of particles at nanosites. And tomorrow we will cover those areas so the cases when you identify the need to apply nano considerations for the risk assessment, and also specifically applicable to engineered materials, but also to these conventional materials with a fraction of nanoparticles. So we will explain both ones. As already announced in the invitation and before, the meeting will be recorded, and the recording will be available to everybody in the EFSA web. The presentation will be also disseminated in the web. And because of the number of participants, we have asked you only to use the chat function. So video and audio connections are provided only to the speakers. And just a reminder to the speakers, please take your video and audio off while you are not presenting. For the rest, please use the chat function in order to put your questions. So use the chat during the presentation, but also during the break. In the chat, you will see also the like function that you can use in case that there is a question that you feel is relevant for you as well, posed by another participants. We will try to use this information to select the questions that are much more relevant. We want to have a meeting that is interactive. It's obviously there are technical difficulties for the online meetings, and also with the number of participants, it's impossible to keep the camera and the opportunity to speak to everybody. But please put your name, surname, and also your organization at the beginning of your question in the chat, and then the speaker's name, my name or whatever, for or EFSA in general, in order to clarify the presenter to which your question is specifically addressed. Depending on the number of questions, if we have received a large number of questions, we will have no capacity to respond to everything. So we will think that it will be much more relevant in order to satisfy the needs of everybody, that we compile questions. So we will use the chat and the questions in the chat to identify the question with more relevant to you. That's why the like function is very important for us. And also to put general questions based on the more specific questions. And the questions will be answered orally during the dedicated Q&A session. I will not open the floor for questions immediately after the presentation, only through the Q&A. Because of the number of participants, we thought that that was the best approach. And also we will prepare frequently asked questions after the meeting. So we will put the specific questions there. We will try to generalize the questions in order to have a document that is relevant for everybody. If you have a particular question that you feel that has not been covered properly during the meeting, or you have a follow-up questions, please remember that you have always the possibility to use the function as EFSA, and then the colleagues will respond to you properly. Just to remember, you can subscribe or receive alerts from us through Twitter, LinkedIn, or to contact us. And also that in June, we will have the one conference, one health, one environment, one society, and the registration is open. It will be an hybrid event, partly present in Brussels and also online. So thank you very much. With that, I will move to the program. And as you see in the program, it's my pleasure to give the floor to my colleague, Sara de Berardis, that will present the key elements from the EFSA catalog of support initiatives during the life cycle of applications for regulated products. This is the information that is provided by the colleagues in the SARA units that provide support to the applicants. Sarah, please, the floor is yours.
Thank you, Jose. Just a second, you should be able to see my presentation on the screen. So before entering into the science, good morning, everybody. I'm here today for a short presentation on the EFSA Catalogue of Support Initiatives. My name is Sara De Berardis. I'm a scientific officer in the Front Desk and Workforce Planning Unit, the new FDP unit, which is the continuation of the Applications Desk, the UpDesk unit you may be more familiar with. Let's start with where to find the catalogue. The catalogue is available on the EFSA website. By clicking on the application section, you will find the banner directing you to the latest version of the catalogue. The latest version was published last year in March 2021. I recommend you to always check on the website for the latest version, as we are periodically looking into the need for updating this document. So please make sure you are accessing the most updated version. What is the catalogue? The catalogue is a technical report of EFSA listing the harmonized initiatives targeted to applicants, but also available to member states and industry representatives that are currently in place in EFSA during the entire application procedure. The aim of this catalogue is to create awareness and understanding of the opportunities for dialogue with EFSA, and also encourage applicants to use the catalogue and to request the services offered. The catalogue provides a description of each initiative, and you can find, for example, information on the nature and the scope of each service, the format, the type of outcome you can expect, or how to request the service. It includes also services that are targeted to small and medium-sized enterprises. And in its latest version, the catalogue also includes the new possibility of interaction with EFSA that were introduced by the Transparency Regulation, and I'm specifically referring to the general and renewal pre-submission advice. To guide you into the different initiatives, we have divided the application lifecycle in 4 different phases, and the catalogue will present you the initiatives that are available across the different phases from the pre-submission to the post-adoption. You can see that there are services that are specific for specific stages of the application procedure. They can be requested only in those phases. There are also a number of services that are available throughout the application lifecycle at any time, for example, the EFSA guidance documents. We have also services that are not linked to a specific phase, but are organized by EFSA with larger audience to discuss specific topics with interested parties, like scientific workshop or info sessions or webinars. Today, I will not be able to present you all the services, but I will focus on a few aspects that are relevant across the different food sector areas. I recommend you to consult the catalogue and to go through the description of the different services to learn about possibility for engaging with EFSA. I will start with the general pre-submission advice. We are in the pre-submission phase with the general pre-submission advice, and potential applicants may request general pre-submission advice at any time before submitting the application. The process starts in the Connect EFSA portal, where first you must open a pre-application ID. The pre-application ID can be seen as a folder where to place all pre-submission activities related to a future application. From the pre-application ID, you can insert a request for general pre-submission advice by providing EFSA with a list of questions and all information that can put us in the position to give you the best support in relation to the applicable rules and content for an application. We recommend to submit a general pre-submission advice request at least 6 months before submission of the application, so to be able to take into consideration our advice. A list of questions is an essential element for the general pre-submission advice. In the absence of a list of questions, we will not be able to provide any advice. So here you find some practical consideration, and we recommend that questions are formulated with a level of details enabling us to understand exactly what is your doubt. So yes, requests should be concise, but please make sure that we have enough element to reply in a constructive way. It is very important to note that the design of the studies is outside the scope of the general pre-submission advice unless the study design is addressed in EFSA guidance documents. If this is the case, we can explain the content of the guidance, but we cannot provide targeted advice on how to develop a specific study or hypothesis to be tested. This remains applicants' responsibility. To let you understand, the advice is indeed general, so in principle applicable to any other applicants who is asking the same question in the same regulated product area. Other elements that are out of scope of the general pre-submission advice are risk management questions, including questions on whether a product may fall in a specific regulated area, and also any aspects going beyond the information available in the applicable legislation and guidance. For these questions, we remind you to ask the risk managers. To give you an idea, so far we have received 44 requests for general pre-submission advice, and we had to reject 18, either because there was no list of questions or because they were out of scope. So very important to keep this consideration in mind when preparing a request for general pre-submission advice. On the toolkit section in the application webpage, you can find a list of supporting material, and we invite you specifically to consult the user guide for information on how to create a pre-application ID and how to request a general pre-submission advice. Now let's move to another service. I would like to spend a few words on the Ask EFSA question. This is another tool through which you can ask questions to EFSA. It is accessible through the Connect EFSA portal. When accessing the portal, you have the possibility to consult the frequently asked questions, and I recommend you to check if an answer is already provided before asking your question. If you are a registered user, you can log in into the portal before asking your question, so you will be able to retrieve the question posed and also consult the answers provided through the portal. This is the form that you will have to fill in when asking a question. You can ask any question related to administrative and scientific issues, to guidance documents requirements, procedural steps, status of specific applications, and also question on IT tools. I'm referring to Connect EFSA, to the Portalino, the e-submission food chain platform, iEuclid, and we respond in the shortest time possible, and anyway, we are committed to reply within 15 working days. You may have noticed some overlap in the scope of the general pre-submission advice and the Ask a Question service. For example, if you have a question on the content of an application, it is likely that will be related to the guidance documents, and you have the possibility to ask questions on the guidance documents also via the Ask a Question service. So here, I think it is very important to clarify that in case a question is related to a single application and it's a question from a potential applicant that is arising during the pre-submission phase, then this question must be submitted via the general pre-submission advice. If instead it is a general question and it's not related to the preparation of a specific application or not coming from the potential applicant or its consultant, then you can use the Ask a Question service. But I would like to highlight here that requests from potential applicants falling within the scope of the general pre-submission advice will not be replied via Ask a Question. We will ask you to resubmit using the general pre-submission advice form. Moving to other services, I wish to highlight an important possibility for direct interaction with EFSA at different stages by requesting a clarification teleconference. As you can see, there are different types of clarification teleconferences depending on the phase of the application procedure. During the completeness or suitability check, during the risk assessment, or after the adoption of a scientific output. Let's focus first on the first two types of clarification teleconferences. They can be requested by the applicant or also offered by EFSA when considered needed. They are organized following a request for information that is sent by EFSA to the applicant. These teleconferences offer the possibility to clarify the questions posed by EFSA to make sure that applicants have full understanding of the request in order to prepare the answer. So we recommend to take advantage of this possibility and to request a clarification teleconference if you have any doubt on the request for information sent by EFSA during the evaluation. With a different purpose, the post-adoption teleconference may be organized on request by the applicant after the adoption of an opinion. In this occasion, EFSA explains the scientific reasoning behind the final output and can clarify any recommendation that is included in the output or the sources of evidence that were used. In this context, it is important to note that EFSA cannot provide any pre-assessment or any advice to applicants for future submissions. Here, an overview of the services provided last year. You can see that the most requested services were the renewal pre-submission advice and the clarification teleconferences during risk assessment. We have also received almost 1,500 questions on scientific application process. Half of them were triggered by the implementation of the transparency regulation. As I said before, you can find the description of each service in the catalogue. Last year, we have also delivered 6 webinars, and this year we have completed the series dedicated to the application procedure to guide you into the changes brought by the transparency regulation in the different food sector areas. If you have missed them, you can find here the links to access the recordings. And finally, to conclude, although it is not included in the catalogue, we have recently launched a new LinkedIn group, EFSA Support to Applicants, where you can find information and updates that may be of interest for you, and where you can interact with your peers. To give you an example, we have recently published a post on a new user guide on confidentiality, and I recommend you to check. If you're not yet part of the group, you can follow the link and join us on LinkedIn. And with this, I thank you for your attention. Back to you, Jose.
Thank you very much, Sarah, for the very clear presentation. As already indicated, we will collect all the questions later for the dedicated Q&A. So please remember if you have any question for Sarah, please use the chat, and she will join us later for the Q&A session. We will then start with the session 1, which is how to establish the presence of small particles in food and feed applications. This is covered by the guidance on the technical particle requirements, and I will be the floor to my colleague Maria Chiara Astuto, for introducing the guidance.
Thanks a lot, Jose, and good morning, everyone. I'm Maria Chiara Stuto, and I'm indeed part of the EFSA Nano team. I will now provide you with an overview of the EFSA guidance on particle requirements and propose appraisal routes to establish the presence of small particles in food and feed application. So, Jose, can you confirm that you can see correctly the presentation?
Yes.
Okay, thank you. So let's start. Before starting, I would like to introduce you the concept of nanoscale and why a specific assessment is needed. So generally, nanoscale can be defined as the size range within 1 and 100 nanometers. However, as you may know, size is not the only information that matters, but we retain at the nanoscale all material retaining properties which are characteristic of it. This sometimes includes a size range that goes up to 250 nanometers. So these properties includes sometimes a different toxicokinetic and toxicodynamic that nanoparticle may have with respect to their corresponding non-nanoform. And examples of these are, for instance, differential uptake that nanoparticle may have due to their smaller size range, as well as different physicochemical properties due to their larger surface volume ratio. Here you see an overview of examples of EFSA's application requiring nanoscale considerations. We can say that the large majorities of applications require nanoscale consideration within EFSA dossier consists in materials containing nanoparticles rather than nanomaterials which are engineered as such. Examples in this case are, for instance, in the field of novel food, where nanoparticle could be added to improve quality of food and increase nutrients bioavailability. In the field of food additives and flavorings and feed additives, where nanoparticles may be added in order to increase shelf life and enhance colors and flavors. And lastly, in the case of novel food, where nanocomposite material may be used in order to develop sustainable smart packaging and sensor to optimize and monitor product shelf life. So here you see an overview of the EFSA Nano Guidances, which will be the focus indeed of this workshop. These guidances were developed in order to address potential nanoscale consideration within EFSA applications and should be considered as complementary between them and among sectorial guidance documents. Today, we will focus, as mentioned by Jose, on the guidance on particle technical requirement that should be considered as applicable to all kinds of application coming to EFSA. Tomorrow, my colleague Irene will present you an overview of the guidance on nanorisk assessment. But before starting the description of the guidance on particle technical requirement, here you can see some of the short and recent history of the nano guidances development and the players that were involved during this process. So let's say that the recent history started in 2018, where, as you may remember, EFSA published the EFSA Scientific Committee Guidance on Nanotechnology for the first year of pilot phase. After 1 year, the pilot phase ended, and in the meantime, EFSA received a mandate from the European Commission for the creation of a new guidance, a guidance on particle technical requirement. After 1 year of work, we published this guidance for public consultation in order to gather the feedback of both the private and the public sector. And then the year later, the last summer 2021, both guidances were published in the EFSA journal. Through this journey, let's say, different players were involved. Of course, the working group on nanotechnologies that is today with us. Also EFSA panels and units dealing with the regulated product, but also European member state through the Nano Network and sister agencies such as ECA, JRC, but also DG Sante. We engage also with other stakeholders of EFSA, such as applicants, through dedicated stakeholder event and also through the public consultation. This feedback was very helpful for us to improve the practical applicability of these guidances. So let's start now with the description of the guidance on particle technical requirements. As a background, it's important to underline that from the nano, let's say, point of view, EFSA may receive 2 types of application. The first one is the case of materials that meet the definition of engineered nanomaterial, And this case falls under the applicability domain of the 2018 Nano Guidances, so that was firstly published in 2018 and that has been now updated recently in summer 2021. Regarding the second case, this is also the most recurrent one, as I mentioned before, and this is related to conventional material which do not meet the definition of engineered nanomaterial, but may contain particles, including particles at the nanoscale. And for this second and most recurrent class of chemicals, let's say, we did not have any risk assessment procedures in place before the creation of this guidance on particle technical requirement. So this was exactly triggered the European Commission mandate that EFSA received in September 2019 in order to develop a technical guidance setting out the information requirement for application in the regulated food and feed product areas of conventional material which do not meet the definition of engineered nanomaterial. So the aim was, first of all, to demonstrate whether a portion or the whole of the material is actually in the nanoscale, and if so, to provide information requirement in order to demonstrate that the nanoscale fraction was properly covered in the safety studies available. The audience for this guidance are, of course, applicants as well as EFSA panels and units when assessing the information submitted. And here, instead, you can see how the cross-cutting working group on nanotechnologies and the EFSA Scientific Committee decided to address the terms of reference that were received. So, first of all, it is important to mention that this document is aimed at guiding the process to decide whether of the material or not the material does require specific assessment of properties at the nanoscale, providing ways for confirming that a conventional risk assessment is sufficient. Here in this right part of the decision process, which describes how the terms of reference were interpreted, you can indeed see that this guidance should be considered as complementary to sectorial guidances, and that if this guidance is not able to conclude that conventional risk assessment is not sufficient, then the user is directed to the guidance on nanomaterial risk assessment that will be presented to you tomorrow. As you can see in the left part of this decision process scheme, the applicant is encouraged to select different appraisal routes, and in particular the best available with respect to the data he has, in order to demonstrate or the absence of a fraction of small particle, or that actually the material contains this fraction, but that this is covered by the conventional risk assessment and sectorial guidance document, and therefore does not require an additional separate assessment for the nanoscale. For doing this sometimes complex exercise, the guidance provides information that are related to best practices for reporting and assessing existing information. Here you can see the core, therefore, of this guidance that are the appraisal routes proposed: solubility, dissolution rate, screening of particle size, quantification of particle size, and coverage by existing studies. These appraisal routes are extensively described in dedicated sections of these guidances and are proposed in order of cost and complexity. However, this should not be considered as a tied approach. As I mentioned before, the applicant is encouraged to select the best appraisal route or the best combination of them in order to exclude the need for nano-specific risk assessment. So here you can see the aim for each clusters of appraisal routes. In particular, for solubility and dissolution rate, the aim is to demonstrate that the consumer will not be exposed to small particles, but they will be, in case present, fully dissolved in the food matrix or in the gastrointestinal tract. Regarding the second cluster of appraisal routes, the aim is to demonstrate the absence or the quantity of small particles in properly dispersed samples. And then we will see why having properly dispersed samples is key for the representativeness of the materials. The last appraisal route is the coverage by existing studies, and here the aim is to demonstrate that even if the fraction of small particles is maybe present, this is properly covered by existing toxicological studies. Here you see examples of application and link with other guidance document of this guidance through the decision process scheme that is taken from the guidance. So for instance, in case of zinc oxide nanoparticles, as they are proposed and engineered as such, the user is directed to the use of the guidance on nanomaterial risk assessment. And so further specific nano consideration are needed. Regarding, for instance, the case of potassium chloride as food additive, here the user is directed to this guidance, but solubility in this case, so a very quick screening, may confirm that the guidance on food additives is sufficient and no nanospecific risk assessment is further needed. Regarding, for instance, the highly discussed titanium dioxide case, here the presence of a fraction of small particles was confirmed by the specification, and therefore the assessment focused on demonstrating that this fraction was properly covered by the existing safety studies. So let's start with the description of the appraisal route. As I mentioned before, the first one, the simplest one in order of complexity, is the one of solubility, solubility in water or solubility dissolution in a marketed product or in food. In particular, this appraisal route is targeted to highly soluble materials that are of low concern or material that will dissolve in the food or in the marketed product. Regarding solubility in water, the appraisal route is met, so decision criteria is met if the value, the substance is a solubility value that is equal or higher than 33.3 gram per liter. And we will see later on what are the principles for selecting this threshold. The methodology used for this assessment should be a nano-adapted OECD test guideline 105, where particle in suspension should be removed through the ultrafiltration as recommended methodology. Regarding the solubility dissolution in the marketed product in food, in this case, the intended use should be considered, and therefore the applicant should be able to demonstrate that at the expected maximum level, the substance is fully dissolved in an aqueous or a non-aqueous matrix, or that the residues in food are below the relevant solubility limit. So here, the results should confirm that under the intended use condition, the material or its residues in food will be fully solubilized in the product that is ingested by the consumers. And here you see that specific provisions in the guidance are described for food contact material substances and for residues in food. In particular for FCM, a specific solubility limit is set to 60 milligram per liters, that, as you may know, is considered to be the generic upper migration limit for this kind of substances. So in this case, if solubility is greater than this value, then the substance will be in fully solubilized form and not present as particles. Regarding the second case, residues in food, so related to feed additive and pesticide, here verifiable information that solubility of the residues is above the maximum levels ensures that the consumers are only exposed to solubilized materials and not to particles. Okay, so here we are at the second appraisal routes proposed in order of complexity, the dissolution rate. This appraisal route is targeted to materials that would dissolve in the gastrointestinal tract after ingestion. Here, the decision criteria is met if the applicant is able to demonstrate that the material has an half-life of 10 minutes or less, corresponding to dissolved fraction equal or higher than 88% in 30 minutes. What is important here is that a single concentration to exposure at the maximum use level in water different time point is measured, and for this the guidance described a specific dissolution protocol in a dedicated section. And here we are at the principles for the selection of this first cluster of appraisal routes. This particular section of the guidance was introduced after the public consultation. Regarding the solubility threshold, the value of 33.3 gram per liter is based on the internationally agreed standard testing for chemicals from JACFA and European US Pharmacopoeia. And the concept behind is that the material is expected to be fully solubilized, and the concept is selected in harmonization with the SCCS guidance on nanomaterials of 2019. Regarding the dissolution rate, here the rationale is a bit more complex. And in particular, the threshold here considers the time needed for particles to cross the mucous layer lining the intestinal epithelium and subsequent cellular uptake. So here, if the particle dissolve within this time frame, then there is no systemic exposure to them. Regarding the concentration to be tested, that is estimated based on the assumption that the amount ingested per day is diluted in the gastrointestinal tract up to a volume of 2 liters. So in case of, for instance, acidic condition of the stomach, such as in fasted state condition or in the assessment for infants and children, adaptation to the volume to 1 liter is needed. Okay, here we are at the next appraisal route proposed, that is of course a more complex one, and is the screening of particle size, which is targeted for those material where it is possible to demonstrate the absence of small particles below 500 nanometers. So here what is important to demonstrate is that the detection capability of the method used for this assessment should provide convincing evidence that the material contains less than 10% of particles with at least one dimension that is smaller than 500 nanometers. Several methodologies are described and proposed in the guidance, such as CLS, particle tracking analysis, descriptive electron microscopy, filtration complemented with chemical analysis, but still different methodologies can be used if duly and scientifically justified. For this step, what is really key and important is to ensure proper dispersion of the material. And for these reasons, a specific section on recommendation for ensuring proper dispersion is reported in the guidance. Through this representation, you can see explained why it is so important proper dispersion of the test material. So, due to their higher surface volume ratio, nanoparticles have this higher tendency with respect to non-nanoforms to form larger size agglomerates via weak forces. This agglomeration, the agglomeration status is therefore a dynamic process and, as you can imagine, is influenced by different physicochemical and biological conditions, especially in the gastrointestinal tract. And this is why ensuring proper dispersion is key for the risk assessment of nanoparticles, as it allows to test a nanosize worst case scenario, that in case of nanoparticles is indeed exposure to them. The next appraisal route proposed, in case it is not possible to demonstrate the absence of a fraction of small particle below 500 nanometers, is the quantification of particle size. Here, the appraisal route is targeted for material where it is possible to demonstrate the presence of just a tail, let's say, of nanoparticles, and the decision criteria is met if the applicant can provide sufficient evidence demonstrating that less than 10% of the particles of the sub 500 nanometer fraction with at least one external dimension smaller than 250 nanometers is provided. Here, as a methodology proposed, is described quantitative electron microscopy, but also here a different method could be used if duly justified. Also in this case, it is important to mention that, of course, proper dispersion of the samples is needed, and even if this criterion is not met, this information will be then required for assessing the fraction of small particle and its coverage by existing studies. Here you see the principles for this second cluster of appraisal routes proposed. So, regarding the screening of particle size, the starting point is that the uptake from the gastrointestinal tract of nanoparticles goes up to a size range of 250 nanometers. Then an uncertainty factor of 2 is considered in order to account for the limitation of available screening techniques. And then assuming that the normal size distribution of the full material, 10% or less of the particles being smaller than 500 nanometers implies that the fraction of nano-sized particles will be minimal and their uptake negligible. Regarding the quantification of particle size, the starting point for the threshold is the same, so use the 250 nanometer as size range for the maximum uptake of particles from the gastrointestinal tract, and then a 10% threshold for the sub 500 nanometer fraction is considered a technical threshold based on the measurement uncertainty that can be achieved under typical conditions with currently available electron microscopy methods. The last chance, so the last appraisal route proposed, is the coverage by existing studies. This is, of course, the most complex appraisal routes and is targeted for material where, even if nanoparticles are present, it can be demonstrated that they are properly covered by existing toxicological studies. So here the applicant has two options. The first one is to demonstrate that the studies address properly the potential hazard of the fraction of small particles, and by doing so, the applicant should demonstrate that all the material is included in the fraction of small particle, and at the same time that the test design and the level of dispersion was sufficient for addressing this fraction. As a methodology for doing this assessment, of course, the characterization of the test material is needed, as well as its comparison with the marketed material. Then specific consideration for this assessment should be done for genotoxicity and toxicokinetic assessment. And in the meantime, demonstration of properly dispersion should be provided. If this is not possible, then the applicant has the last option to demonstrate the coverage by existing studies, and is that the applicant should demonstrate that the gaps observed in the are covered or are of overall low relevance and do not trigger additional concern. So in general, while performing this assessment, there are critical elements that should be considered by the user, which are related to the fact that, as we mentioned before, the exposure to particles represents the worst case scenario. So the first critical element should be considered is that the lack of a proper dispersion method and the use of high doses in toxicological studies promote agglomeration, which results in a disproportionality between internal dose and external dose. So what would happen in this case is, in practice, an apparent non-monotonic dose response that is caused by the fact that particles are present as large agglomerates and are not able to penetrate and be internalized into the cells. The second critical element should be considered is that available studies should have a proper duration, which is at least 90 days, and should provide examination of the first site contacts, such as Bayer patches and gastrointestinal epithelia, with appropriate techniques, such as, for instance, ICP-MS. The last important element to be considered is that, as usual, a complete genotoxicity test battery is needed, but in this case it should be considered that the AIMS is not considered to be a suitable test for the assessment of nanoparticles, and in this case a mammalian gene mutation test should be preferred instead. So here this should be considered as a slight deviation from the EFSA Scientific Committee guidance on genotoxicity assessment of 2011, and this is caused by the fact that nanoparticles would not be uptaken by the bacterial wall. Okay, so lastly, what I would like to highlight is that while doing this complex assessment, the applicant is supported in the guidance by several additional elements, such as, for instance, a table which provides example for combining different lines of evidence and detecting data gaps regarding the coverage of the fraction of a small particle by conventional risk assessment. Then a dedicated section and the recommendation are provided on how to conduct new studies if needed in light of 3R's principles and new approaches methodologies implementation. And then two appendixes are provided in order to describe how to report the characteristic of the fraction of small particles, so in order to support the applicants on the step of the physicochemical characterization. And lastly, another appendix is provided in order to describe how to report information from existing safety studies. Okay, so we are at the end of this presentation, but before giving back the floor to Jose, I would like to highlight here for you 3 take-home messages. So the first one is that besides the sector-specific risk assessment, all conventional material should be evaluated for possible presence of small or nanoparticles according to this guidance. If the application dossier does not provide the sufficient information describing this process, then the applicant is directed to the guidance on nano risk assessment, which will be presented tomorrow. So I thank you very much for your attention and give back to you, Jose. Thank you.
Thank you very much, Chiara, for your presentations, very clear. Nevertheless, we consider that this obviously is a complex guidance, so we want to complement the presentation from Maria Chiara with some examples that will be provided directly by the members of the working group on the nanotechnologies. So I will share my screen. I'm going to put in presentation mode. So the first group will be a set of examples related to the assessment of solubility and dissolution and particle size distribution. Will be provided by 4 of the members of the cross-cutting working group from the scientific committee: Francesco Cubada, Jan Mas, Hubert Rosert, and Stefan Weber. And I will start with Francesco with the solubility and dissolution rate. Francesco, please, if you can put on your camera and give us through the presentation.
Yes, good morning. Thank you very much, Jose. In this first presentation, we compiled, as said, some examples for the appraisal routes, which are addressed in chapters 2 and 3 of the guidance. And the selection of these examples was based on issues emerged in the assessment of real cases of products potentially containing small particles. So we are a bit expanding on this in this presentation. So the first appraisal route is the one connected to solubility, and the related one, the dissolution rate. Indeed, it is important to realize that the dissolution rate is a sort of key element in the sense that it is the one linked to human physiology. And it is important indeed to appraise if under the anticipated use conditions, the material will be fully dissolved. This can be happen at different level. This can happen in the marketed product, in the food, or following ingestion during the gastrointestinal processes. So what is key is the demonstration that dissolution kinetics is rapid enough to achieve full solubilization in the stomach or in the intestine before any gastrointestinal uptake of the particles. And a simplified dissolution rate is offered. Basically, it is an assay in water with modified ionic strength with addition of sodium bicarbonate and sodium chloride. And if the solubility is pH dependent, and the criterion is not achieved as neutral pH, it can be demonstrated that the dissolution rate at pH 3, which represent the stomach conditions, is sufficiently rapid. For infants, pH 5 is considered to be more physiologically relevant. As a surrogate, as we have already seen, solubility threshold is offered as the first appraisal route because it is a very simple approach. And the rationale, as already explained, is that if the solubility is very high, the solution is assumed to be sufficiently fast. And we already have seen that solubility test is based on the OECD guidelines with modified with an ultrafiltration step to exclude the presence of small particles in suspension. Next, please. Another important element is the ultrafiltration step, which is considered to be the reference method to separate particulate and soluble fractions whenever a suspension is suspected to be present instead of a solution. Solution means no particles present in the medium. Suspension or dispersion means that particles are there. As such, ultrafiltration is mentioned in several parts of the guidance for the testing of solubility in water, for the assessment of dissolution rate in water, for confirmation of absence of particles for liquid materials, and also as a potential screening method for the presence of small particles when assessing their size distribution as a screening approach. However, we realize that in some cases there might be challenges in applying these, especially where large macromolecules are present, which may be retained by the membrane during ultrafiltration, even though they don't have a particulate nature. And sequential filtration steps may help in this case, as shown in the figure below. But if the issue is not solved, an argument may be put forward that the substance is not a particulate one and supported with adequate experimental evidence. Next, please. Another very important element is the dispersion protocol. Dispersion protocol is frequently mentioned, and the need for this is highlighted in different parts of the guidance. A proper sample dispersion is important in the first step in the assessment of dissolution rate in water, so to the agglomerate potential agglomerates. Again, the need for proper sample dispersion is mentioned in the characterization of the size distribution of the material for the size distribution of the fraction of small particles, and it is explained that all measurements of particle size distribution need a proper dispersion of the sample, and specific recommendations are given, and some general steps are also highlighted, so some background is given to design an appropriate dispersion protocol, which entails the choice of the media and any predispersion or wetting, the choice of the method for the agglomeration, and also including the input energy, and the stabilization of the dispersion. Finally, the dispersion protocol is key in the safety studies. So the level of dispersion and degree of agglomeration of the test material has to be adequate for assessing the hazard of small particles, including nanoparticles. So that's all for my part. Hubert, over to you.
Thank you, Francesco. So the next point are cover the screening. So Hubert.
Good morning, everyone. So I continue in the decision tree. We have now passed the solubility criterion and the solution speed criterion. So we have now come to the screening step to screen for the presence of particles that are smaller than 500 nanometers. So this is the first step. The question is whether the material contains a fraction of small particles, and in this case, 500 nanometer or smaller. And the technical guidance says that the applicant has the possibility to confirm using so-called screening methods that the material contains less than 10% of the particles in a number-based distribution that are smaller than 500 nanometer. So the screening methods that can be used for this have been mentioned already by Maria Chiara in the presentation. In the guidance, there are listed centrifugal liquid sedimentation, particle tracking analysis, descriptive electron microscopy, and filtration with chemical analysis. And the applicant can use other methods with justification. So the screening methods, to remember, can be used or possible to demonstrate that less than 10% of these particles have at least one dimension smaller than 500 nanometer. So they could give a positive indication whether a given material contains small particles. But of course, it's screening. So these methods usually cannot distinguish whether a given material has aggregates or agglomerates, because it cannot distinguish individual particles from these types of agglomerates and aggregates. And also it cannot be used to obtain a quantitative number-based size distribution of the particles. Regarding screening electron microscopy, that give also an indication of the agglomeration and aggregation state of a sample. And it can also give an indication of the particle shape, which is also useful for the following steps. Next slide, please. So often other methods are used, but some of those should really not be used. They cannot be used to screen the presence of small particles, according to the technical guidance, although they're quite common in the labs. So one of those methods is dynamic light scattering that is not suitable for obtaining a good number-based particle size distribution. But it may be relevant for the checking of the stability of dispersions, which I will show in one of the next slides. Then laser diffraction is usually not good enough in the very small particles with a size small, let's say smaller than 100 nanometer. It is unable to measure these particles in general. Volume-specific surface area is also a method that can be used to characterize the material, but it cannot be used to assess a material, whether it follows these thresholds as indicated in the technical guidance, this 500 and 250 nanometer, to relate the size distribution to these thresholds. So it should not be used and cannot be used for screening. And also to remind you, whatever the method used, a number-based particle size distribution has to be reported. Yes, and so it is also often a problem that such methods cannot distinguish between agglomerates and constituent particles, which would make them also not useful for the screening step. Next slide, please. So a few more remarks about dynamic light scattering and laser diffraction. Probably you know that the dynamic light scattering is based on a measurement of the fluctuation of the scattered light caused by the Brownian motion of the particles, whereas laser diffraction measures the light scattered by the particles. So the scatterers in this with these two methods, there could be individual particles, aggregates, or agglomerates. So as mentioned before, these methods cannot distinguish between larger individual particles and aggregates or agglomerates because the measured quantity is different. All these two methods, they measure many entities simultaneously, not particle by particle, but many particles in one measurement. So they call sometimes ensemble methods. And the measurand for dynamic light scattering is the hydrodynamic diameter of equivalent spheres. So that would be spheres that move in the same speed through a liquid as the measured particles. So therefore, it is particularly unsuitable to characterize non-spherical particles because it would give a rather wrong impression of the size of these particles. Laser diffraction measures the equivalent spherical diameter as well. So the DLS, the results are light intensity weighted, and that means because the scattering is proportional to the 6th power of the diameter or the radius, it gives much more weight to large particles. So a particle of 50 nanometer diameter compared to a particle of 5 nanometer diameter, the one with the 50 nanometer diameter would the scattering intensity would be 10 to the power of 6 stronger. And because of all this, conversion into number weighted results is not reliable, and it is and if there is a mixture of small and large particles, the smaller particles are often hidden it cannot be detected. And therefore, a DLS alone, and likewise laser diffraction, cannot be used to prove the absence of small particles. And if you want to know more about DLS, there are two sources that can be consulted. Next slide, please. Just a small example, a rather old example, quite instructive, what DLS cannot do. For example, in this example, there were 3 dispersions prepared, gold nanoparticles of 5 nanometer diameter, 15 nanometer diameter, 45 nanometer diameter. And in the upper panel, these dispersions, the suspensions, have been measured individually. And then the result is overlaid in that panel. So we can see the red curve for the 5 nanometer, the green for the 15, and the blue one for the 45 as an overlay. But when you put these particles in a mixture in one suspension, and even make a mixture that the three types of particles, the 3 sizes, have the same mass contribution, 1 to 1 to 1 in mass. That means the number of the small particles has to be much larger than those of the big ones to have an equal mass distribution. And measure that mixture, one gets a signal that is almost the same as the one for the 45 nanometers. So that demonstrates the small particles, they are hidden, and if there are even bigger particles, the smaller particles, it would be very difficult to detect them. Next slide, please. But what it can do, for example, dynamic light scattering are other things that are very useful for other things. For example, to find the optimum dispersion parameters. For example, when a dispersion is prepared through sonication, the agglomerates are broken up as the dispersion energy increases. So on the lower side of that figure, you see that with increasing dispersion energy, the particle size as determined by DLS has an asymptotic trend. That means the sonication energy is enough and dispersion is okay. On the upper panel, you see that when the dispersion energy increases, there is aggregation, or sometimes called coagulation. With increasing energy, particles aggregate again. So this is not a good way to disperse, to prepare that kind of sample. Next slide, please. And finally, also DLS can be used to measure the stability, or to check the stability of dispersion. In the right panel, you see that both the red and the blue curves indicating the particle size, the blue one, and the count rate, the red one, are constant over time. And that means the dispersion is stable over time, at least in the measured time frame. And that is okay, it's good, it's a stable dispersion. On the left side, you see another case. These particles are much larger, and although the particle size is measured by DLS, the derived particle size stays constant over time, the count rate decreases, and that means the particles sediment. So we have a strong sedimentation, and the dispersion is not stable in this respect. Could also be the case that the derived particle size with time changes. For example, that the derived particle size would move to smaller sizes. That means dispersion is also not stable due to, for example, sedimentation of larger particles or due to agglomeration. So it can be used for specific purposes, but not for this criterion what I was talking about, to prove that the material has less than 10% of particles smaller than 500 nanometers. And with this, I stop here and give the word to my colleague Stefan, who continues with the volume-specific surface area. Thank you.
Yes, thank you, Hubert. Just some more words on the VSSA. It's a very simple technique, so it's quite tempting to use for screening purposes. However, for the requirements we have in the guidance here, it's not fulfilling these the main reason already is that it does not provide particle number size distributions. But even if you were accepting that, it only provides a very simple correlation of surface area with size only, which is only valid if you have truly spherical, non-porous and monomodal, monodisperse and non-aggregate particles, which is usually not the case for food-grade materials. So we very seldom have these requirements in real-world materials and not in research materials. So in this sense, it's not suited to exclude materials from consideration. I mean, it's possible to include them, but the other way around, it's not suited to say or to prove that in a given material, no particles below the size ranges indicated in the guidance are present. So this is just to confirm that. And with that, I would hand over or finalize the screening method we had before and hand over to Jan for the EM.
Electron microscopy is proposed as a method to determine the number-based size distribution of particles. And it's important that it's properly provided. I will walk you through the different steps of a typical EM analysis, which aims to clearly report how the work and the workflow is realized, and to show that the measurement results are precise and accurate for a representative population of particles and in the context of the guidance of the constituent particles. Next slide, please. The first step in a typical EM analysis is the sample preparation, and the aim of the first step is to have a stable dispersion, because in the most dispersed state, a deagglomeration is obtained, and although electron microscopy can work with a certain level of agglomeration, it will make things much more simple. Yeah. The principles to obtain such a stable dispersion is to make sure that environmental conditions, so there's the pH, the amount of salts, the polarity and the type of medium, and the protein concentration are compatible with a stable dispersion, because we want to obtain a deagglomerated or deaggregated conditions, for example, by adjusting the pH. I will give an example, and by sonication. Electrospherical stabilization in certain cases can be an option, and then this can be based on proteins like BSA or on surfactants. And if concentration is too low, one can increase the concentration of particles, for example, by centrifugation. Now, many of you will know the generic dispersion protocols like the nanogenotox and the nanorig protocols that are used to prepare dispersions for cell cultures or in vivo experiments. They can work, but in most cases, they obtain a suboptimal dispersion. For physicochemical characterization, a more specialized protocol, as described, for example, for titanium dioxide by Guillot and Spalla, are advisable. Often, in general, the dispersion protocol has to be tailored for a specific material. Next slide, please. I have included this example to show that it is very much worth the effort to optimize the dispersion. We are looking here at electron microscopy pictures of NM102, a titanium dioxide representative test material distributed by GRC that is difficult to disperse. And when you look at the zeta potential curve, you can see that there are two zones where there is an extreme zeta potential, meaning that a stable situation can be expected. In the acidic zone, and you can see a basic zone. Now, for an acidic pH, you can see that there is almost a perfect dispersion of the constituent particles that can easily be measured. Aggregates are very small. They were measured and they were 33 nanometer. One would expect a similar situation at pH 7, but having a closer look, it turns out that at this pH, the situation is not stable and that many of the particles are agglomerated. In this case, pH 2 is clearly better than pH 7. Next slide, please. The next step of the workflow of electron microscopy analysis is the specimen preparation. This step aims to transfer a representative fraction of particles to the support of an EM grid. And allow me to say that it is in many cases much more practical to use EM grid that also can be glued to stubs because they give a much better control. And you can obtain a uniform distribution of your particles with a minimal overlap. Now I refer to the picture. You can see that there are different steps. In the first step, first box, you make sure that the charge of the particles is compatible with the charge of your grid. In this case, a positive charge, Alcium blue, is deposited on the grid so that the negative particles that need to be tested will stick strongly to the grid. The particles can be deposited in the next step on the grid using different protocols, and afterwards it's often necessary to wash and dry to avoid that there will be precipitation of salts on your EM grid that could be mistakenly for particles. Now, with respect to the type of protocol to deposit your particles on the grid, there are a number of possibilities. In case of a stable dispersion, the grid-on-drop deposition method can be considered as the default method. If one would be interested in agglomerates, one can consider using the drop-on-grid deposition methods. In case you want to have all the material on your grid in a concentrated way, on-grid ultracentrifugation is possible. And there are cases, for example, when you have to analyze platelets, where specialized sample preparation methods or specimen preparation methods are necessary, for example, embedding in resins and ultra-thin sectioning. It's important to very clearly think the goals and the limitations of your approach. Next slide, please. The EM imaging is in fact the most technical step in the entire workflow. It aims to obtain a number of representative micrographs, and is the first phase where you can see whether your previous steps were successful. So you can see whether the material is deagglomerated. You can see whether the relevant particles can be identified or they're pure enough. You can see whether there are enough particles on your grid and whether concentration is needed. Often, if this is not the case, you have to start again with the sample preparation. Now, it is important that you have a representative sampling and systematic random imaging, for example, at predefined position on your grid can strongly assist to that. In many of the reports that we got at EFSA, we saw that there were difficulties with the selection of the magnification. Now, this is very well described. With respect to the magnification, it's all determined by the pixel size, and the criterion of Merkus can be used as a rule of thumb. It defines that the smallest dimension of the smallest particle in your population should be at least 10 pixels. And from then, the magnification can be elaborated. The upper limit of quantification is determined by the ISO size, and this is 1/10 of the image size. It assures you that you will not eliminate the larger particles that are on the border of your picture. With respect to the number of analyzed particles, there are a number of approaches, but one of the best is to express the measurement uncertainty in function of the number of particles in function of the measurement uncertainty. And this allows you to objectively determine the number of particles that you need to obtain measurement with a certain precision. Now, with respect of what type of electron microscopy you're going to use, the imaging mode, often this is determined by the fact that this device is present in a lab or not. You have to make sure that you select the correct device. For example, scanning electron microscopy usually has a resolution that is larger than 10 nanometer. If your population contains particles smaller than 10 nanometer, scanning electron microscopy is usually not suitable. Transmission electron microscopy has not this problem, but can have problems in case, for example, if the preparation is relatively impure and it is difficult to identify the particles. In such case, a STEM ADX approach, which also detects the chemical, where the signal is also determined by the chemical proposition, is advised. Next slide, please. Image analysis. Image analysis can be done manually, but more and more specialized software are available that allow to do this type of measurements much more efficient. With respect to reporting, it is very important to clearly mention what type of software is used, what type of protocol is used, and I've given you a table at the right side of my slide, which gives the different steps in such a protocol, and what type of algorithm is used to identify the particles. There is an evolution towards more increased performance and also more complex software, and more operator bias disappears. You do not do manual measurement anymore because machine learning algorithms are taking over. It's important in reports that besides the normal electron micrographs, also the annotated pictures showing how the particles are identified are given. At the left bottom of my slide, you can see that for a number of examples, how the constituent particles are efficiently identified in a number of nanoparticles. Next slide, please. The last step of EM analysis is data analysis. In the technical guidance, we measure the constituent particle size, which is an intrinsic material property, not influenced by the environmental conditions, and we determine the number-based size distribution of the particles smaller than 500 nanometer. It is important to select the proper size parameter. We want to measure the minimal external dimension of the constituent particles, which can be used by a number of measurements. GRC has given a number of guidelines, for example, in the GRC concepts and terms, which measurement best should be selected. The minimum ferrite diameter in many cases is applied. It can also be used for manual measurement. In certain cases, the maximal inscribed circular diameter is more efficient, but it's not efficient to use the equivalent circular diameter unless your particles are perfect spheres, and certainly not the maximal ferrite diameter because you will miss the minimal dimension. Of course, you will give the number-based size distribution, as you can see on the right, and in addition, a number of descriptive statistics, which are usually given by your software. Yeah? And there are ISO standards that describe how to calculate them. In many cases, it's very useful to also provide with the raw data so that if something would be missing, at least you can go back to the raw data. Now, so far I discussed mostly constituent particle size. In the nano guidance, also other parameters like size, shape, surface topology, agglomeration, and aggregation are asked for, which are important for risk analysis. These also can be determined by electron microscopy. Thank you. Now I go back to Stefan, I think.
Yes, thank you, Jan. Stefan, please.
Yes, finally, some words on quality assurance. Well, similar to conventional analytical methods, of course, also in the nano area, we have to make sure that the methods which are used are fit for purpose, and this also has to be shown. So usually the methods to be used should have undergone validation and determine the relevant parameters, for example, detection limit, precision, trueness, and more details on this are given in the scientific guidance. What we ask to report is always the measurement uncertainty. So it should be determined from either from intra-lab or inter-lab validation data, in particular the precision data, of course. It must be reported with each result. And then an extended measurement uncertainty should be reported using a factor of 2, which relates to a confidence interval of 95%. So this needs to be taken into account when considering the results with view to the thresholds given in the guidance. And I mean, this should be obvious, but from the cases we had, we concluded it's good to give a reminder on this. So next.
So thank you very much. So we have also specific elements that are linked to the specific substances or specific considerations. And the members of the working group have also prepared a second presentation with that cover other considerations or specific elements for specific substances that are very relevant to EFSA. Has been prepared by Jacqueline Castermeiler, Kasim Chowdhury, Francesco Cubada, and Roland Franz. And I will give the floor first to Kasim for the first presentation. Kasim, please.
Thank you very much, Jose. I'm going to explain some basic parameters that define why risk assessment of nanomaterials, nanoparticles is different from conventional bulk material. And in doing so, I'm hoping that I will reinforce some of the messages that you have already heard from other talks. When we consider a chemical and a nanoparticle form of the same chemical, we immediately see that chemical aspects, for example, chemical composition, chemical identity, etc., are same. So they share the same composition and various chemical properties. However, when a chemical is in nanoparticle form, it has a dual personality. It has a chemical nature, which will obviously be matching with the chemical in the bulk form. But it also has a particle form, a physical particle form. Next slide, please. In that form, there are certain aspects which define what the shape and size and other physical parameters of that chemical has become. And then there are kinetic and functional aspects. And you already heard that as particles become smaller and smaller, they tend to, first of all, agglomerate more and more, and hence we will see that the agglomeration of material dispersions becomes very important. But also that smaller size gives them much more surface reactivity, much more surface area compared to bulk materials, and also a potential ability to cross biological membranes. And that is where further concerns arise. Where do these particles potentially can end up in the body, where other particles are not allowed to go? And that is which makes risk assessment of a nanomaterial, nanoparticle form of a chemical different from risk assessment of the bulk material form of the same chemical. And for that reason, if we have already data on a chemical, and we normally have lots of data for normal bulk chemicals, that cannot be used straightforward to risk assess nanoform of the same material. And there are certain aspects which have been already highlighted, chemical aspects and how to measure particle parameters and kinetic parameters. And these together have to be considered for a nanomaterial risk assessment. So next slide, please. Now, first thing that, as I mentioned, that because of high surface free energy on nanoparticles, they tend to stick together. I mean, if you consider like dust particles, they are very sticky, very clingy. And if you start making nanoparticles at the nanoscale, they become more and more clingy. So they have lots of free energy on the surface. And these can be deglomerated. And this is, as it was mentioned in Maria Cara's talk, that this is a dynamic process. And we have to consider that adequate dispersion has been conducted, which is very essential. Then solubility, dissolution, insoluble nanoparticles in a solvent will not be soluble. They may look like that they have a uniform dispersion or they disappear from visual sight and the solution or the dispersion looks a solution, but effectively they will be in a nano dispersion, nano suspension form when you start looking at the electron microscope or something. So then stability of dispersion is therefore essential. So they have to be dispersed, and then not only that, but during the test, that dispersion needs to be stable. Then nanoparticles may stick to other surfaces and sediment out of suspension. And this is important if someone is carrying out, for example, an in vitro test, because nanoparticles may coagulate, may agglomerate, and may stick to glass and plastic vehicle surfaces. And the uniformity may be lost. So uniformity of the dose under conditions is therefore essential. Then there are certain surface characteristics because nanoparticles can bind and absorb or adsorb certain other substances and may carry them into cells and tissues. And they may also interfere with the assay readout, specifically if they are colored nanoparticles or they reflect light in a certain wavelength. The thorough characterization of the test material is therefore essential. So if you could go to the next slide, please, Jose. So bioavailability, as I mentioned, surface chemistry, surface modification, coatings, etc. It is known that they influence properties. Cells and tissues do not see nanoparticles. They see what is on the outside. And if on the outside there is something which is allowed in the cells, those nanoparticles will be allowed to enter into the cell. They will hitchhike that mechanism. So not only nanoparticle, core nanoparticle, but what is on the surface, has any chemical modification been made? Is any coating applied? That needs to be considered as part of the risk assessment. Depending on the nanomaterial, the route of exposure, nanoparticles may cross biological membranes, as I mentioned. Data on toxicokinetics of nanomaterials is therefore very, very essential. When we have nanoparticles and they are insoluble particles and they cannot be exited by one of the appraisal routes mentioned in the previous talks, then they have to be considered. Where do they go in the body? Not only what they are, but where do they go in the body potentially? If you could go to the next slide, please. The dose metrics, we are all used to using mass per volume and mass per mass, kind of milligram per liter and milligram per kilogram kind of dose matrices. But here we have particles as well. So in this case, it may be that those metrics do not properly reflect the toxicological measurement of the effect. And the effect may be better described in particle number, particle surface area, etc. And one needs to consider that as well. Then, because normally at nanoscale, the particles may have catalytic surfaces, and investigating surface reactivity is also essential to see whether they can cause some local effects or some internal effects as well. Nanoparticles may interact with biological entities close to molecular level. They are so small that not only that they will have a physical presence, but also that physical presence is close to molecular level. So this is something we need to consider in the designing toxicological studies so that they can capture some of those aspects as well. If you could go to the next slide, please. Then obviously estimation of local and systemic exposure, not only to nanoparticles, but also any released ions and moieties from the nanoparticles, because nanoparticles, okay, they may enter into the cells, but they may also act as a reservoir for continually releasing ions where they are. Examples are like silver and zinc oxide and those kind of nanoparticles. Next slide, please. The other aspect which I want to highlight is that there is a perception that nanoparticles are mainly made of inorganic substances, and that is not true. Nanoparticles, nanomaterials may also be composed of organic as well as hybrid inorganic mixture nanomaterials, as well as inorganic materials. So potentially they can be made from any material. Numerous examples of nanoforms of organic substances are already known, and they are already examples outside Europe mainly. Food supplements, preservatives, nutraceuticals, vitamins, antioxidants, etc. And this is actually one reason why the whole food supplement area is adopting these nano forms of supplements, vitamins, antioxidants, nutraceuticals, etc. Because there is some evidence that in the nano form, these materials are absorbed and taken up in the body much more than the conventional bulk forms. Then organic nanomaterials have been used to develop nanoscale delivery systems, and this has opened up another big avenue on the lines of nanomedicines, where various bioactive substances such as biocides, pesticides, human and veterinary medicines, etc., are embedded within the nanoscale delivery systems to enhance uptake, bioavailability, and stability of the formulations as well. Could we go to the next slide, please? In many cases, organic substances are used from natural origins, and then applicants tend to declare that they are safe because they are from natural origin. But unlike inorganic nanomaterials, safety concerns equally apply to organic materials, because reasons are that properties, behavior, and toxicokinetics of organic and inorganic substances equally can change at the nanoscale. The other aspect is the nanoforms of many organic materials have been reported for much greater absorption and bioavailability compared to the same substance of conventional bulk form. Increased uptake and bioavailability of certain substances may cause adverse health effects in itself, even if the substance is safe in the bulk form. If the bioavailability uptake in the body goes highly up, then there might be cause for some adverse effects. Organic substances in nanoparticle form may also cross biological membranes and barriers and reach various parts. It equally applies to organic substances. If nanoparticles of an organic substance are internalized by cells and tissues, they may act as a reservoir that continues to release molecular ionic forms over a long period of time. And this needs to be also considered equally for organic substances like organic nanomaterials, like inorganic nanomaterials. Can we go to the next slide, Jose, please? Therefore, the take-home message is the nanoforms of organic or natural materials should not be automatically assumed as safe on the basis of data corresponding to bulk form. Someone thinks that a vitamin, an antioxidant or whatever is safe in the bulk form, conventional form, its nano form must not be taken automatically as safe. Safety assessment of nanoforms of organic natural substances must also consider additional small particle-related aspects. A particular account should be taken of any changes in physicochemical and biokinetic properties of nanoforms in comparison with the conventional bulk form. So this is the take-home message, that nanomaterials, nanoparticles may not only be of inorganic in nature, but may also be made of organic substances. And even if those organic substances are food-derived, plant-derived, animal-derived, naturally derived, and are considered safe, But when they are in nanoparticle form, one must consider what changes have happened in their physicochemical properties, in their biokinetic behavior that might be of concern. So I think this is the last slide for me, Jose.
Thank you very much, Jose. So we move to Francesco.
Thank you. And I continue from the previous speaker with organic materials and address specifically the case of small lipophilic organic particles, which may happen to appear in some products. They may be present as small particles, including nanoparticles. And if they are not marketed in a lipophilic media, which would cause the dissolution of these particles, they will maintain the particulate nature when ingested. They are expected not to dissolve in general in the gastrointestinal tract because of their lipophilic nature, and thus they can be assumed to reach the human intestine as particles. There they can follow the uptake route of lipids and dissolve and partition to physiologically hydrophobic environments. This is an option which may happen. And in order to explore this option information on the physicochemical properties, for instance, solubility in lipophilic media, and the coefficient of tunnel water, and along with toxicokinetic information and use level is very important. Next slide, please. Based on this information, gastrointestinal uptake may be shown to be linked to the conventional processes for the absorption of lipids and lipophilic materials by the intestinal epithelium. For instance, by passive transport through the cellular membranes and then partitioning to physiologically lipophilic environments. So it is very important to consider this option and to substantiate this possible process. It is also important to distinguish endogenous substances, for instance, vitamin metabolites, where conventional risk assessment may be valid, and information should be compiled supporting this appraisal route. For exogenous components, special care has to be exercised in order to provide a reason and justification as to why this appraisal route may apply, in which, again, toxicokinetic information, uptake, and distribution data are essential. Next slide, please. A special case is that of truly engineered nanomaterials. In this case, as we all know, these materials, when used as ingredient in a food, are classified as a novel food. This means that this type of materials or products based on these materials have to be assessed according to two guidances, the novel food guidance and the nano guidance. If the material is also a nutrient source, it has to be appraised according to three guidance: the novel food, the nutrient source, and the nano guidance. For nutrient sources, it is essential to show if and when the material joins the body pool of the nutrient. And by doing this, falls under control of homeostatic mechanisms. It is essential to demonstrate if particles enter the systemic circulation, which of course have a lot of implications, or if this does not happen. So this is really a key aspect, and any difference compared to the normal dietary sources of the nutrient has to be investigated. So integrated approaches to testing and assessment, including new approach methodologies, are very important. Of course, they have to be adapted to tackle specifically the nano aspects, and they are overall essential to provide mechanistic knowledge underpinning this type of assessment. Thank you, and I hand over to Roland.
Francesco. First of all, good morning to everybody. we are coming now to food contact materials. In this slide, I will show you shortly and concisely why and where nanomaterials are used in food contact materials. We have, in general, three major areas of applications for nanomaterials in FCMs. The first one is just to technical, mechanical improvements in the properties of packaging materials like flexibility, etc., temperature, moisture, stability. And the other important issue is here to improve barrier properties against gases, moisture, taint, organic chemicals, and including also UV light. The second large area is the one of active packaging, where antimicrobial nanomaterials or oxygen scavengers have the purpose, the task to keep packaged food hygienic and fresh for longer. And the third large area is the one of intelligent packaging, where nanochemical or biosensors can have a potential to indicate to the consumer the quality and freshness status of packaged foodstuffs. Finally, we should not forget also nano coatings. These are very thin layers which are brought on matrices like polymers, for instance, by plastic deposition techniques of inorganic material like silica. And the purpose of these coatings is to make antimicrobial and self-cleaning food contact surfaces and or to generate barrier layers which would reduce migration from food contact materials or would reduce absorption of food constituents into material. Next, please. And this, of course, it needs to be said here that concerns over consumer safety from nanoparticle exposure arise, of course, only if nanoparticles are released by migration or abrasion from food contact materials into food. Next, please. As food contact materials have their own rules and characteristics when it comes to exposure, it's just as simple as that the substance first has to be released from a food contact material before it can come to consumer exposure. And therefore, a special solubility threshold was to be defined in the guidance. And this was already mentioned by Maria Chiara, but here I'm going to present this more in detail. What you see, the key aspect, if you would have a nanocomposite, a food contact material containing solid nanoparticles, and when they may transfer to the food in contact with it, then the question is, would these particles dissolve? Would they come into solution, into ionic species, for instance, or into molecules, depending on the type and nature of the nano? Then the question is, the point is then, if no, this would then go to nano-specific risk assessment, and if yes, if it would sufficiently and rapidly dissolve, this would qualify then for conventional risk assessment. Next, please. For the adaptation of the solubility criterion to FCM substances, the following considerations and thoughts are essential. The first key consideration is that migration of nanoparticles from nanocomposites, from polymer nanocomposites, is where it generally go, if any at all. And this would of consumer exposure from the consumption of foods that was packed in such nanocomposite FCMs. And therefore, against the solubility criterion, the one with 33.3 grams per liter, as provided in the guidance, special considerations for small particles or nanoparticles in FCM should, just because an FCM substance may transfer from the FCM into food at very low level, that is, however, fully solubilized, and even though that this substance may have an intrinsic solubility lower than the 33.2 grams per liter. And this discrepancy, which arises especially for the special case of FCM substances, was addressed in the guidelines. And how it was addressed, we'll see that in the next slide, please. The starting point is the EU Regulation 10/2011, which sets approach migration limits for non-genotoxic substances, currently between 50 ppb and 60 milligram per kilogram or milligram per liter when we talk about food simulants. And this regulation sets an upper generic migration limit for FCM substances of 60 milligram per kilogram. That means FCM substance has a solubility higher than 60 milligram per liter, then its migration, its transfer from the food contact material can be considered to be, at the end of the day, so to say, when it in the exposure form, fully solubilized and not be present as particles. And here it should be noted that if migration would really exceed 60 milligram per liter, then from a risk assessment point of view, it would be irrelevant whether this would be in solubilized form or in particle form, because the FCM substance would not comply with the legislative limit and will not be allowed. And this can be measured by gravimetrical measurements or by chemical analysis. Therefore, the risk assessment guidance was changed, was a say that a conventional risk assessment should be sufficient for a substance which has a solubility higher than 60 milligram per liter, when its migration can be considered to be in solubilized form on the basis of solubility data or tests or dissolution rate testing, or when it can be demonstrated that it is soluble under worst case time temperature food contact conditions for the packaging before the food is ingested. So that's all I have to say. The take-home message here is, regardless to the solubility criterion of 33.3 grams per liter for food contact material substances, it is we have a special arrangement which is set at 60 milligram per kilogram. That's all I have to say. Thank you for your attention. I give back to Jose.
Thank you very much, Roland. Thank you very much to all the experts from the Nano Working Group. We are reaching the time for a break. We have seen a lot of activity in the chat, so thanks a lot for putting your questions. That's also for highlighting the questions more relevant for you. We will need half an hour for digesting these questions and prepare a very nice question and answer session. So we have a delay of 10 minutes, but we want to keep the break of a half an hour. So please do not so keep your connection. Yes, I will stop my camera and the microphone, and we will be back at 11:25. So half an hour from now. Thank you very much, and we will see you in the next session to try to respond all your questions. Enjoy your break and your coffee or tea. Thank you. So welcome back. I hope that you have been happy time for taking coffee or tea or something. In the meantime, we were collecting the specific questions. Thanks a lot. It's a large number of questions. That means that there is interest in this meeting, which is really appreciated. We are trying to do our best for collecting the questions with more interest, and that can be also of general interest. Again, I remember that after the meeting, we will produce a Q&A document that will be available and will be published, and that, as Sarah was mentioning this morning, you have a set of specific opportunities for requesting advice on specific applications of your interest. we want to keep the timing for the other presentation, so we will have a little bit shorter question and answer session now, but then we will move and have all the questions answered later on. We have also blocks after the presentation from the external speakers as well as tomorrow. With that, I could give the, so we have the first question is for Sarah. That
Jose, I will project the.
Yeah, Irene, if you can project the question, please.
Yeah, just tell me if you can see it.
Yep, we can see it.
Perfect.
So Sarah, as you can see, there are two questions for you. The first one, if it is possible for EFSA in the pre-submission advice to enter more deeper into the scientific aspects.
Yes, thank you. Here I can clarify that the scope of the general pre-submission advice is defined by the law. The transparency regulation clearly says that EFSA should not address the design of the study in the context of the general pre-submission advice. This is an important difference compared to the renewal pre-submission advice, where EFSA can provide advice on the content of the renewal application and on the study design. So we operate in this context, and the general pre-submission advice is meant to explain the data requirements. The responsibility to decide on the study design and on the testing strategy remains in the hands of the applicant. But although we cannot enter in these aspects and we cannot provide any pre-assessment or validate any protocol, still we can give important clarifications that are beneficial for the preparation of the application and to submit dossier of good quality. And with this, I connect with the second question. In the spirit of the law, there's a clear intention to help also small, medium-sized enterprise comply with the requirements. And in this perspective, EFSA is continuing with the support to SMEs. So the services, the support initiatives that are described in the catalog for SMEs are there and still available. I may flag that we have centralized the support, and the mailbox dedicated to the SME office has been dismissed. This will be reflected in the next version of the catalog. So if you contact us there, you will receive a message redirecting you to the Ask a Question service. But this was done exclusively with the intention to provide a better support. So let me also remind you that for some services, we need to receive the SME status assessment, and you find information in the catalog on when this is needed and also on how to get it.
Thank you very much, Sarah. We can move to the second question. It's a general question on the applicability of the guidance, and I will give the floor to Jacqueline. Jacqueline Castelmeiler is one of the experts in the working group. Jacqueline, please.
Yes, I think I can be very brief. This guidance is applicable to all materials, and you cannot just refer to the sectoral guidance documents. And we have explained this in the other document, in the EFSA guidance on nano risk assessment, where we have included a figure where we explain, and text of course, where we explain the relationship between these guidances and the sectoral guidances. So I guess we come to that tomorrow. But the simple answer is yes, it's applicable to all materials. And no, it's not enough to refer just to the sectoral guidance.
Thank you very much, Jacqueline. And also a reminder that this guidance was produced from the mandate from the Commission, and both the mandates of from the Commission and also the interpretation by the EFSA Scientific Committee with the extension to other substances is already transparently reported in the guidance as well. With that, we can move to the third question. And I will, this is on the technical requirement for particles, and I hope that Jan, you can respond to it.
Yes. Is it required to determine the particle size distribution for each substance applied for? No, not for all. For example, when a substance is soluble or has a high dissolution rate, then no particle size distribution has to be provided. Yeah. When this is needed, how can the reporting of particle size characterization be done? They refer to the 500 nanometer threshold. The 500 nanometer threshold is a tool to make things practical, to help the applicants. In an ideal world, we would ask to give the full number-based size distribution of all the particles. In practice, we have limitations of materials. The key question here is, are there small particles present? Small particles are the one that can be taken up in the gastrointestinal tract, namely those smaller than 250 nanometer. And you compare this fraction to the two larger particles, namely the particles smaller than 500 nanometer. This avoids that we have to combine particle size distribution of several methods simultaneously.
Thank you, Jan. So we can move to the next question. Is on the concept of aggregation and agglomeration, and I pass the floor to Kasim for answering this question. Kasim, please.
Thank you very much, Jose. The difference between aggregation and agglomeration is that in aggregated state, particles are strongly bound together, either chemically or like metal bonds or something else. And they are not easily disaggregated, and especially under normal physiological conditions. So they form bigger lumps, and okay, they have bigger surface area, internal and external, but they are not likely to disintegrate into particles, small particles again, unless you apply some special techniques. In agglomeration, they are held with not very strong forces or not bound together. They are held with weak forces like electrostatic interactions or hydrogen bonding or van der Waals forces. And these are where, although they may appear as bigger lumps of as particles together, but under certain conditions, if pH changes, if concentration changes or physical force is there, they can disagglomerate, and they will come back into the kind of free particle form. So in risk assessment, it is a key consideration because in risk assessment, you consider the worst case scenario. So dispersion of particles to disagglomerate any agglomerated particles is important so that we are presenting in the test situation the worst possible scenario that can happen in the body. Thank you.
Thank you very much, Kasim. So we can move to the next question. We go to the concept of constituent particles, primary and secondary particles, and I will pass the floor to Hubert. Hubert, please.
Yes, thank you. One very short answer to this is that the term constituent particles is explained in the glossary of the technical recommendations, and there it says the constituent particles are morphologically identifiable particles, including those inside aggregates or agglomerates. So that means so this is clear then. However, it has been realized that the term constituent particle often creates some confusion. That is why it is also explicitly explained in the glossary. And the reason why it creates confusion, maybe if I may briefly explain this, is that this term constituent particle in itself is incomplete, because when we talk about constituent particles, we need to know what it refers to, so the point of reference. So what the constituent of what, and this is the decisive point. So it has been mentioned, the ISO interpretation and the interpretation by the European Commission in the nanomaterial definition. It is simply the difference is the point of reference. So in the ISO definition, constituent refers to aggregates and agglomerates, whereas in the interpretation by as used in the Commission, the point of reference is the entire material, so the entire sample. So in this sense, The term constituent particles, as used in the technical recommendations here, follows the interpretation of the European Commission that also individual particles in the materials are considered as constituent particles of the materials. And likewise, the constituent particles, aggregates and agglomerates are also constituent particles of the whole material. So this is the difference. And of course, aggregates can be part of larger entities, agglomerates, and therefore yes, they can be part. So it is always important when we meet the term constituent particles to be very clear about the point of reference. And for the EFSA, for here, it is the whole material, whereas for the ISO, it is just the aggregates and agglomerates. When keeping this apart helps. And I would also mention in the end that in the OECD is developing test guideline referring to the size measurement of small particles, nanoparticles, where this terminology, I think it is clarified more. But for our purposes, I think it is clear, and have a look at the glossary. Thank you. I think that's primary and secondary particles, I forgot, is a different concept. The primary particles are considered as those particles originating from a nucleation process, growing, and then they can form aggregates and agglomerates. So the primary particles can still be individual particles, but also the original particles of the aggregates and agglomerates. And the secondary particles are exactly the aggregates and agglomerates. So, this is a term that should not be confused with each other. Primary particle, for example, if a particle splits off from an agglomerate, it would be again an individual particle, but it could not be called primary particle anymore. Thanks.
Thank you very much, Hubert. So we can move to the next question. This is a question on the size definition and the recommendation for the novel food. I will take. I think this is a question for EFSA, but also for the European Commission, for DG Santé. So I will start with the response, and then I will pass the floor to my colleague from DG Santé, Takis Daskaleros. So my first clarification is linked to the mandate from the Commission. So the mandate from the Commission specifically referred the need to assess the presence of a fraction of nanoparticles in conventional materials. So materials that do not cover the definition of engineering nanomaterials in the Novel Food Regulation, but nevertheless, from the scientific perspective, so for the risk assessment to ensure the protection of the consumers, we will need to be sure that the material, even if it is a conventional material, has been assessed properly through the EFSA panels and working groups, considering the fraction of nanoparticles when that fraction of nanoparticles is relevant because consumers will be exposed. And this is the full basis of this guidance. So it's not a guidance to define if a material is or is not a nanomaterial. It's just the risk assessment part is a material that is conventional, but nevertheless require specific assessments from the scientific perspective at the nanoscale. And Takis, do you want to complement also regarding the recommendations or something else? So it seems that we have a problem with the connection. So then we will move to the next question. So I'm sorry. So sorry, we have a problem with the connection because our colleague from the DG Santé is muted. May I ask my colleagues to unmute Takis if possible? But it is sorry. We will need to. So we will sorry Takis. For tomorrow, we will be sure that you have the capacity to do that. So I will keep this response for you later. So we need to move to the next question. Is on the biological basis for the 250 nanometers, and I will pass the floor to Agnes. Agnes, please.
Thank you. So let me first say that there is indeed a limited knowledge base on the uptake and the relationship to size. But it's clear that there is a relationship with size. So smaller particles can be taken up better than larger particles. But there are also other properties that are relevant for the uptake across the gastrointestinal tract, like shape and surface properties. But at least we can say that, well, in general, what we know now is there's an optimum of uptake around 50 nanometers with potential uptake up to 250 nanometers. And this is further, so if the real references would be relevant, please have a look at the EFSA guidance on nano risk assessment that will also be presented tomorrow at page 56 and 57. And as a last comment, it's not completely excluded that even larger particles can be taken up, but this is more what we see as a general uptake limit. Thank you. Back to you, Jose.
Thank you, Agnes. So we can move to the next question. Is related to the solubility and the OECD guidelines as well ultrafiltration? I will pass the floor to Francesco.
Thank you very much. So the issue here is what is the correct methodology to assess solubility for the purpose we are considering, that is potential presence of small particles in the material. It is important to apply a modification of the OECD guideline, which is well explained in the guidance. And the reason is why the conceptual basis of the guidelines is that a material when going through the dissolution process is identified by potentially two phases. There is a solid phase and a liquid phase, and it is important to keep this in mind because the entire test is based on the separation of these two phases. So it is assumed that the solubility is the maximum concentration, where at equilibrium there is only the water phase or the liquid phase present. And when a solid phase starts to separate, this is the solubility threshold. The problem is that if there are small particles, these small particles will remain in the liquid phase, and they will be floating in the liquid phase, and assuming these small particles as part of the liquid phase would lead to an overestimation of the solubility. More importantly, these small particles are exactly what we are looking for. So we are missing them and erroneously attribute them to the liquid phase, whereas in fact they maintain their particulate nature as separate solid bodies within the liquid phase. So it is necessary to avoid this artifact by applying ultrafiltration. And ultrafiltration is simply an approach to take out these particles from the liquid phase and be sure that the concentration measured is represented only by a liquid phase without an heterogeneous system, also including solid small particles. So this is the basis, and this is well explained with some details in the guidance. Of course, this is what can be said in general as an approach, but for very specific materials, modifications and adaptations might be necessary. So applicants are always welcome to propose a reasoned justification for any approach which is taken, which has to be based on science and solid evidence. Thank you.
Thank you very much, Francesco. And I received the message from the colleagues that the problem with the TACIS has been solved, so we can move back to question 6. And I hope that this time technology works So Takis, you have the floor.
Can you hear me?
Yes, we can hear you now.
Yes.
Perfect. Thank you.
Thank you. Good morning to everybody. Basically, I really don't want to add anything other than what Jose said. I think we need to make a very clear distinction for the colleagues that are following from the outside the Commission. This guidance request was really delinked, if you wish, from the regulatory aspects of the nano definition in the food sector. First of all, please, for the purposes of this discussion, the general definition of nanomaterials does not apply. It's a very simple thing. We're talking about the only definition that applies in the food sector, and that in a few regulated areas, novel foods, food additives, is really the engineered nanomaterial definition of the novel food regulations. So that's very clear. So really the links with the general definition under the Commission recommendation of 2011 are there, but the definition we do follow in the food sector is the one in the novel foods. So that's the first thing to clarify. The second thing to clarify, as Jose mentioned very eloquently, the mandate was really simply for those materials who do not fit or do not comply with the engineered nanomaterial definition. In other words, we have the definition which speaks of size and how you do chemically or size-wise define the material as a nanomaterial. And then there's the safety elements that have to come in. And there we have the guidance for the risk assessment of nanomaterials, in our case, engineered nanomaterials. And this mandate was really to cover the gap, if you wish, in the safety for the fact that there may be some materials which do not meet the definition. They're conventional materials, but may contain a fraction in a small scale, also in a nano scale. Now, in setting the mandate, we did not in any way deviate from the definition of the regulation of the 100 nanometers. I think the 250 or up to 500 is, and I think Jose and Jacqueline explained it, it has to do with the fact that when it comes to safety and behavior in biological systems, some materials above 100 nanometers may behave differently than the conventional brethren. So really the deviation was really a science-driven from the technical guidance, from the experts that really worked on this, rather than from the Commission and the mandate that we gave, okay? Because the idea here, again, the technical guidance is really to address the safety aspect of small particles. So I think I complemented a little bit and I explained the situation when it comes from the regulation. Thank you.
Thank you very much, Takis. And I think it's a pleasure to have DG Santé with us to give clarifications. So with that, we will close this first session of question and answer. Obviously, we will have one after the presentation from the external speakers and then also two blocks tomorrow. But one of the key elements of this event is to give the opportunity to applicants, interested parties, laboratories that have already tried and have already succeeded in the application of this guidance to present both challenges but also opportunities that they have encountered, and to discuss between all what could be the next steps and how these two guidances can be implemented. We offer to several organizations, and we are glad to have received 5 organizations that have kindly offered to be present as speakers. We have 3 presentations this morning and 2 presentations tomorrow. And I'm very glad. First, I will like to thank all of you for your willingness to present your case and your experience. And we will start with the first one. Please use the chat for the questions. We will do the same, the 3 presentations together, and after that I will open the question and answer, starting with the presentation from the external speakers. The first presenter is Gat Olivier Afir plus William Blanc-Bosse from Amazentis, and you will present the challenges for the companies for following the EFSA small particles and nanoparticle guidance in food. Gat, William, the floor is yours.
Thank you so much, Dr. Tarazova. And we are very happy, to join you for that session. First of all, do you hear us clearly?
We can hear you. If you can put your presentation.
Yeah, we are about to share the presentation. Perfect. And just to introduce ourselves quickly, and we are about to respect also the timing. I know that this is a key topic. So, okay, I'm sharing my desktop, and please let me know if you can see it.
Yeah, we can see presentation. Yeah.
Excellent. So,
yeah.
First of all, I would like to thank EFSA for inviting Amazentis to present today. Dr. William Blanco and myself are very pleased to join that nano session and the workshop that you organize. So we would like to describe the content of the presentation, but before that we go further, I will give the floor to my colleague William, who would like to introduce himself, I'm sure.
Hi, everyone. I'm very happy to be participating in this conference. I think it's really great that EFSA has organized this and is really educational, and look forward to sharing our experience implementing the guidance. Pass back to you, Ken.
Thank you, William. William is in charge of all the regulatory aspect at Amazentis, also a pharmacologist by background, and myself, Gad Olivier Arfi. I'm a registered toxicologist in Europe and in charge of quality and safety at Amazentis. So thank you very much again for welcoming us. So the content of our presentation will cover three dimensions, three aspects. So the first one is a review of the guidance as seen through the eyes of the industry, because we think that it should be important, for the different applicant and for the different organization to see how we were reviewing the guidance, and this will make the link with the second chapter, which is practical application of the guidance, how we were making it live. And the third one, the third chapter will be key learnings from following the EFSA guidance that we would like to share with EFSA and with the team in order to go further following your presentation from this morning. So the first chapter, which is the review of the guidance as seen through the eyes of the industry, we'll start, with different elements that have been already discussed, from this morning, from Sarah, from Maria, from Francisco, and I'm very happy to see that we are aligned. So the first challenge, that we were facing was the size as a key driver for nanomaterial behavior. And when we mean about size, the first challenge is about definition. So when we think about definition, as referred by EFSA experts today, there is the European Commission definition, which is talking about 50% or more of the particles in the size between 1 nanometer and 100 nanometers. There is, as you know, also the ISO and the 26567 EN guideline, which is under review, which is compiling, the different nano definitions for all the different countries. And the third one, which is part of our workshop today, which is the EFSA definition with the characterization of small particles in general. And as it was mentioned today, having a focus on the particle distribution below 500 nanometers, and within the 500 nanometers, focusing on the part of the particles which are below 250. So this is where we were starting, understanding the different key definitions, applying the guidance using EFSA definition. The second challenge that applicants may face is also the particle size distribution, because measuring, the three dimensions can be also difficult. Determining one of the dimension has a nano dimension. And based on the distribution of the particles, especially if we are talking about a powder, this can be a challenge and a measurement via the electronic microscopy. When we were going further, of course, the third challenge was the agglomeration and aggregation, and we are talking about that also today, because small particles have the tendency to stick together and to form some agglomerates or aggregates. And that was part of the questions that we were facing. Do we talk about agglomerate, aggregates? What is the current pH that is used in comparison to the body fluid? Because we're talking about food and potentially food supplement. And based on that body fluid type and the hydrodynamic size, we can, also simulate the physiological body condition. So we are also thinking on the application of the guidance to conduct our risk assessment. And as it has been said by EFSA expert, because we are all, of course, applying quality and food safety principles, the validation of the method and the verification of the uncertainty was key for us. I would like also to mention Dr. Lothar Escher, who is a regulatory toxicologist from the Swiss Center of Applied Human Toxicology, and the University of Basel, who participated also into insights for that presentation. And I thank you very much, Dr. Escher. So when we move forward, we were discussing about different aspects of the nanomaterial, discussing with different stakeholders, and my colleague William will continue in that way. What we would like to share with you is really our learnings and what we discovered during the application of the guidance. So moving forward, let's see the practical application of the guidance.
Okay, thank you, Gab. For the practical application of the guidance, we set out to basically identify CROs. If you could go to the next, and basically CROs that are familiar with particle size characterization, and then from that group, if you go to the next one, we were looking for CROs that were familiar with EFSA's guidance on particle size characterization. And then I'm going to share with you a bit about the investment that both in time and money that we had on this, and then finally the response that the results that we got from EFSA on the feedback. So on the guidance, as you are familiar, I'm sure most of the people on this, the guidances are very thorough, and I'd say that it's great to have this session to kind of unpack a bit of the guidance, because the problem with these guidances is, I would say the advantage is the thoroughness, but also the difficulty or the challenge to have groups go through it. And so what we found was that when we reached out to CROs that would help us on particle size characterization, many of them were familiar with particle size characterization, mostly for pharmaceutical products, but they were less familiar with the EFSA guidance, and this is not surprising, being that it's a new guidance. However, they were really having difficulty, or there was really a reluctance to follow this guidance, and people would basically, the groups, when we discussed with them, they would say, we would share the guidances with them. They would say, oh yes, we will look at it. We will keep the studies in basically in compliance with this guidance. But in actuality, they would perform the study as they have done for other groups for other applications. And so this meant that there was not the justifications that were required or that have been asked for EFSA. And so this led to a higher level investment from our point of view, in that basically we would perform the study with one group. It turned out that wouldn't be in compliance. We'd have to repeat the study. We went through 4 different groups before we came to a group that really had the expertise that we needed. So I would say I'd really like to underline the fact that it is very important as an applicant to identify a group that's really familiar with this guidance to help you achieve this particle size characterization. And part of that means that the applicant should also make an effort to understand the guidance, even though it is a little thick, so that they can evaluate the CRO and their competence, and perhaps also see if they have experience with other products or other examples that they've managed to get to a successful application. So as I was saying, you know, it's very important because if you don't follow the guidance, you're going to get pushback. So this is what happened. EFSA was like, well, the guidance is clear. These studies aren't matching the guidance. So it's really not something to be overlooked. It's something that is important to do correctly, and it's important to find groups that can do those studies correctly. So next slide. So we'd like to share some of the key learnings that we got from the whole process, and you know, and also some suggestions for the future. And the next slide. So the insights that we had was, first of all, I cannot underestimate the importance of basically using the tools that are available, not only the guidances but also the clarification teleconferences. We've had a lot of support from EFSA on clarification teleconferences on a lot of subjects, including the particle size characterization. I personally think that it would be very good if we could also have some sort of a pre-assessment possibility in these teleconferences. This is not something that is possible currently in EFSA, but it is possible in other regulatory jurisdictions and perhaps should be considered. On the next one. Next point again. So I think these workshops are excellent. I think that I would say this is a very complex subject. There's a lot of different areas, sonication, dispersion, the best conditions for different situations. Is the toxicology studies that I have compliant? Are the dispersions that were done correctly? I think that would be even more helpful if we had these kind of workshops with a more focused and subject and a smaller length of time, and then that would allow people to really participate in a very focused way. Next subject. This I felt would be a great idea that Amazentis, you know, as general, we had really trouble identifying CROs that were qualified for this guidance and for the application of this guidance. If there would be a way to either have a qualification or accreditation or even some sort of like certificate for participating in a course that EFSA gave for CROs, such that applicants could somehow evaluate, you know, the real expertise or the real knowledge of this guidance from CROs. Next, I'll pass it to Gab for the next one.
Thank you so much, William. So, as you see, we would like, you know, to share with you a take-home message with these 5 helpful insights. And the number 4 is creation of FAQs. And I was referring, you know, to the early presentation where you have a very nice portal where we can post different questions. We can also have a catalog of different points that we can see. If you can highlight, you know, the FAQ, or if you can establish a detailed FAQ on specific elements of the guidance, that would be really great. That would be helpful for providers and applicants. The last one that we would like to share with you, that would be really beneficial, you know, to have smaller but more targeted guidances. By example, on sonication, we were, you know, discussing with a lot of experts worldwide about sonication and sonication conditions, and we would be really, you know, grateful to EFSA to set up some specific guidances on key conditions, as we were discussing today, you know, about the particle size, characterization, the sonication conditions, because of the potential aggregation of the different particles. Thank you very much. I would like also to mention that our CEO, Dr. Chris Rinch, participated into that presentation, and we would like also to thank him for his contribution. We would like to share with you our key message at Amazentis: quality and safety, every day, everywhere. This is really what we would like to share with you as an insight to protect the health of the consumer. Thank you very much for your attention. And I'm
Thank you very much.
giving back the floor to Jose and the team.
Thank you very much for your presentation. Very clear, very good. We will, as mentioned, we will collect the questions and then I will pass the questions to you later on. To thanks again with you for sharing the thank you again for sharing your view, and I will move to the next speaker. Is Federico Benetti. Federico, you can put on your camera. Federico will talk about the physicochemical characterization of novel foods. So, Federico, the floor is yours.
Good morning. First of all, I would like to ask you if you can see my screen properly.
We can see, but it's in presenter mode, so we can see also your notes and the now is no. Sorry.
Okay. So
no, now, yeah.
No, it's
now
perfect.
It's okay. Yes.
Okay, thank you very much. First of all, I would like to thank you, EFSA, for the opportunity to present our experience in this topic. I'm Federico Benetti, Director of ECAMRICERT Laboratory, part of Marine Nutri-Science, and I'm going to introduce our experience on physicochemical characterization of, let's say, novel food in light of the two documents and guidelines we discussed this morning. Particle size is an important aspect to be considered in order to characterize properly materials, in order to define if there are nanomaterials or small particles inside the specific ingredient or materials, and then to decide if to apply the guidance on a nano-specific risk assessment or guidance for conventional materials in order to properly address the risk assessment. Based on our experience, there are different techniques that can be applied for investigating the presence of small particles in specific materials. However, electron microscopy is the most recommended one from our experience, since it provides a number-based size distribution and it permits to define if 10% of particles present at least one dimension smaller than 500 nanometers. So I'm going into detail on electron microscopy for particle size determination. Particle size electron microscopy permits to define, of course, the size and shape of particles, as you can see here on the right, crystallographic structure, and coupled with the EDX, also the elemental composition of particles. Electron microscopy permits to discriminate primary particles, constituent particles in isolated form, as you can see here in the picture on the left, or in their agglomerated or aggregated form. However, as described several times this morning, a proper dispersion protocol is suitable in order to disperse agglomerates and aggregates and detect easily or in the easiest way, smallest primary particles. The idea is to, let's say, identify the primary and constituent particles and then define their size. To this aim, we should apply the dispersion protocols before starting with the electron microscopic acquisition. There is not a universally applicable test protocols for preparing stable dispersion of materials and then for characterizing the presence of small particles. However, there are some indications in, for example, standard operating procedures of Nano-Define EU project for some testing materials. Some of them are reported in this slide, such as pigments or, let's say, organic or inorganic nanomaterials. However, starting from these indications, ad hoc and tailor-made dispersion protocol should be applied for a specific ingredient, for a specific materials, in order to avoid any artifacts and define the best conditions to isolate particles. In this regard, here is the approach we use for the samples from the pristine materials. So we start and we try to look at similarities with the materials reported, for example, say in the nano-defined documents, and then we acquired the pristine electron microscopy micrographs in order to look at a qualitative level particle shapes. That's really important in order to see if during sonication we introduce alteration in particles, and then we introduce and generate artifacts. After that, we applied the different sonication energies, and then we acquired electron microscopy for each energy applied to samples in different conditions with different solvents and the presence or absence of surfactants. And then we look at the different micrographs in order to identify the best isolated particles that preserve and maintain the pristine particle shape. As you can see here, the image below on the right describe the, let's say, the proper condition for isolate and deagglomerate particles, while the upper image show the presence of particles with a different shape. So there are artifacts introduced by sonication procedures. Once identified the proper sonication and dispersion protocol procedures, we can start to apply electron microscopy for acquiring images and then to characterize the particle size. Particle size that have three different dimensions, if they are not spherical particles. Length, width, and thickness. As mentioned before, length and thickness are very, let's say, easier to acquire, and then once acquired, we calculated the descriptive parameters in terms of minimum and maximum size and median values, but also D10, D50, and D90 values. In order to acquire the third dimension, we apply the tomography in order to be able to measure also thickness, and then in this way to collect all dimension parameters and descriptive parameters in order to define if there are nanomaterials inside an ingredient or a bulk materials, or if D10 is less than 500 nanometers in order to define if there is or not a small particle fraction. And we described samples from a qualitative point of view in order to indicate magnification range, image analysis, if there are impurities, agglomeration, aggregation states, primary particles, and of course, descriptive parameters. If there is the presence of a small particle fraction, so there are more than 10% of particles below 500 nanometers, we characterize again these small particle fractions in order to define a new D10 values and compare these with the second threshold, 250 nanometers, in order to define if there is a fraction of particles in the nanoscale. It's really critical since depending on the results, you should apply the specific nano risk guidance documents or the guidance for conventional materials. Once identified the particle size and if there are nanomaterials or small particles inside samples, we can apply the solubility tests or the dissolution rates. As described this morning, we use OECD test guideline 105 with the ultrafiltration steps. Or we calculate the dissolution rate, and then if these criteria are met, no additional assessment for small particles is needed. If these criteria are not met, as in this case, since solubility or dissolution rates are less than the threshold established, it is possible to evaluate the solubility or dissolution rates in relevant media, such as matrices used before consumption. In this case, it is possible to mimic the conditions in market products or metrics that are similar to the conditions that in this case, novel food would be used. And then after solubility, we apply the ultrafiltration phase in order to detect the soluble fraction and particulate fraction with well-defined analytical techniques, ICP-MS, if we are referring to metal components or other analytical techniques. If criteria are satisfied, no additional testing is for specific small particles are required. Otherwise, we should consider these particles in a tox test. However, this approach is not so easy, since ultrafiltration and filters are not often compatible with the solvents or metrics used. Here you can see, for example, the passage of copper oxide nanoparticles through the filters in the presence of organic solvent, since it interacts and destroys filters. So filter is not able to keep and retain a particulate fraction. So we should use alternative methods, such as, let's say, the dissolution, and then the investigation by using electron microscopy coupled with the EDX in order to observe remaining particles, or if properly justified, ultracentrifugation and electron microscopy. And in case of nanomaterials, the approach is quite similar. Here I would just introduce our expertise on iron hydroxide adipate tartrate, for which a specific EFSA opinion has been published at the end of last year. This has been, let's say, the applicant was Nemesis, and here we contribute and support Nemesis in defining particle size of particles. As you can see here, particles are well isolated, and then we define the description parameters from minimum to maximum size, the median values 3.1, so it is a nanomaterial, D10, D50, and D19 values. As described in this workflow, then we also applied in vitro gastrointestinal digestion at 3 different concentrations, and then at different time points, at least what time points in the intestinal phases, we evaluate the amount in the excreted fraction and the bioaccessible fraction. In this case, we separate the bioaccessible fraction into different parts, the soluble fraction and the particulate ones, in order to define solubility of YAT. In this case, we applied both fasted and fed conditions in order to mimic and to investigate the oral fate of YAT along the digestive tracts, using 3 different amounts of YAT, 15, 30, and 16 milligrams, with the 30 that represent the daily iron intake suggested. As a control, we also investigated the oral fate of ferrous chloride, since it is ionic control, in order to see if also the ion form tends to form particulates. Here are the results in which we evaluate the amount of iron in the soluble fraction or in the retained fraction. As you can see here, most of the YAT is present in the particulate fraction on the right, while the ionic fraction and the soluble fraction is limited. In order to confirm if we are looking at the artifacts, since nanomaterials can interact with the matrix, so for example, iron can be retained by the matrix, we also further investigate the different fraction, the retained one and the soluble one, by using electron microscopy, where we identified particulates, iron-based particles, with, let's say, descriptive parameters and dimensional parameters that are similar and fully in compliance with the initial materials. So in this way, we confirm that YAT retains its properties, and by using dissolution in GI tract ultrafiltration, but also electron microscopy, we further confirm that data are robust and YAT is not dissolved. Then it has been also applied the stability of the solution in lysosomal fluid in compliance with the indication reported in the guidance document. Since we are in the presence of nanomaterial, we should consider and adapt the toxicity test accordingly to the presence of nanomaterials. As described before, we first of all investigated the stability of nanomaterials and YAT in test conditions, I mean in cell culture medium, when performing OECD 487 test, that means micronucleus. And here you can see DLS that has been used only for evaluating stability a long time in the test conditions. So with the red, that is the cell culture medium, and black and blue are the curves of YAT in test conditions. As you can see here, the main peaks are preserved and maintained, so along the micronucleus test, YAT is stable. Then we also confirm the stability and the not agglomerated or aggregated phase of YAT by using an electron microscopy, as you can see here on the bottom, and then we again perform a quantitative particle size distribution in order to see if median values are in line with the ones of pristine materials, also in micronucleus test conditions. After that, and after exposure of YAT to cells, we also evaluate the cellular uptake of YAT in order to evaluate if the negative results we obtain, so no cytotoxicity was observed, was due to the inability of YAT to be absorbed and uptaken, or it was present but it is fully safe for cells. As you can see here on the left, you observe black dots that have been characterized by using STEM EDX. These particles are composed by iron, so they are YAT particles taken up by cells. And then also in this case, we characterized from a size point of view internalized particles in order to, let's say, adapt and justify all steps since we are in the presence of nanomaterials. Our experience, so I would just summarize the main points. So electron microscopy from our point of view is the most powerful technique to characterize primary particles of either single substances or mixtures from a qualitatively or quantitatively point of view. This permits to define distant values and compare with the thresholds. Dispersion protocols are crucial in order to define and isolate particles and define properly if there are small particles inside samples. There are no specific standard operating procedures for real samples or specific samples, and ad hoc protocols need to be developed. Dispersion protocols could introduce artifacts, so the comparison with pristine material is essential, and also the solvents used for particle dispersion should be carefully evaluated in order to avoid any solubilization process of particles. Solubility in lipophilic media is quite challenging since ultrafiltration could not represent the best way due to the sensitivity of filters, so alternative method should be applied after validation and justification. Validating methods with well-defined performances permit to obtain reliable quantitative data and avoid artifacts. Our idea is that participation to international networks permits to improve our expertise and knowledge on the topic. And then once identified the presence of nanoscale objects or nanomaterials, the adaptation of toxicity tests is very important in order to prove reliable and useful data to properly evaluate safety of the material. I would like to thank all the team and then all of you for the attention. Thank you very much.
Thank you very much, Federico, for the very comprehensive presentation describing. We will have more on IAT tomorrow. We will move to the next presenter for today, which is the last one. Is David Lockley from that they will present on the key challenges when interpreting the EFSA Nano Guidance in the opinion of E171. So, David, if you can put your camera on. Yeah, good morning.
Morning.
And you can start your presentation.
Can you see my slides? Yeah.
We can see the your slides. Perfect. Thank you.
Great.
The floor is
Thanks
yours.
very much for the opportunity to present today. Going to sort of run through some of the TDMA's perspectives on the application of the EFSA Nano Guidance to E171 or titanium dioxide. So I guess as an introduction overall, we were sort of, I guess, concerned in a way because the EFSA Nano Guidance was applied to E171 in the middle of an ongoing risk assessment. And previously, you know, we considered E171 as not really fulfilling the definition of a nanomaterial. Obviously, this morning there's been some clarity on the definition of a nanomaterial under the novel food applications approach. But prior to that, I guess EFSA had considered E171 safe in 4 previous opinions dating back to 2016. And in fact, the studies that were requested by EFSA, which was an extended 1-generation reproduction study to set an ADI for E171, were submitted and showed no adverse results. However, when EFSA applied the new nano guidance across the plethora of studies in the genotoxicity area, all of these studies had already been completed under sort of conventional OECD guidelines. And of course, our study, which was almost complete, didn't apply the framework either. So in the end, on the 6th of May, I think the key conclusions on E171 was really, from our industrial perspective, was a sort of non-conclusion, really. It was just that there was uncertainty about the safety of E171 for the genotoxicity endpoint. So in a way, the mandated application of the new nano guidance changed the outcome in the EFSA opinion. So where does this leave us now? As you can imagine, we spent quite a lot of time reading a very substantive assessment by EFSA, but the industry itself still committed to reduce the uncertainty related around E171 and titanium dioxide in general. And we continue to try to understand the main interpretation points of the document. You know, there's an awful lot of detail in the opinion, and it's taken a long time to sort of work through that. But overall, I think there are 3 areas where we still sort of have some reservations, would like to talk to EFSA on for clarification. So generally, the read-across approach, the nanoscale consideration.
Sorry, David, we are still in your first slide. I'm not sure if you are moving your slides, we cannot see it.
Yeah, I'm moving it through, yeah. I can see it now on my screen.
No, I'm still see the first one.
It's not appearing.
Jose, I think you can change it because I can change it on my screen.
Right. Okay. Now
I'm on slide 3.
Okay, thank you.
So how to change?
Can you see that now? Right, okay. Shall I?
Okay.
So that's 3 now, yeah? Can you see that?
Yes.
Yes.
Okay, brilliant.
Now, yes. Sorry for that.
No problem. Appreciate that. Thank you. So yeah, if I think that we go to the first area, is the read across. So as you know, E171 is a very specific form of TiO2. So it's a untreated, non-surface treated anatase. You can have a rutile version as well. It's a non-nano grade, and it has a very strict purity criteria under the regulations in Europe. And it actually represents only 1% of the TiO2 produced. So, you know, TiO2 is used in an awful lot of applications, but the percentage used in food is small. As I've already said, E171 doesn't meet the EU recommendation of nanomaterials, but we have had some clarification this morning about under the novel food applications. It doesn't contain more than 50% number particles below 100 nanometers, although there is a reasonable percentage within the nano tail. So this is part of the discussion: is are we looking at a true nanomaterial, or are we looking at the nano tail within the material? And EFSA's nano guidance is clearly related to different forms. So it states this on page 3. But therefore, do applicants need to undertake a separate physicochemical characterization and specific risk assessments for each distinct nanomaterial and nanoform? And of course, this builds into the read across, because in the nano area, there's an awful lot of information on P25 because it's in the JRC reference library. It's been used historically in a lot of toxicology studies. But that P25 is distinctly different from E171. I think if we go to the next slide. In the fifth opinion, EFSA applied a read-across approach to consider other forms of TiO2. And as I've said, you know, data on a specialty industrial catalyst grade, P25, which is not used in food and consumers are not generally exposed to, was relied on by EFSA for the evaluation of genotoxicity. So that's a concern for the industry. I guess in a way you have to take all the data in the round, but a catalyst grade doesn't really represent a food grade. But the read across is foreseen in the EFSA guidance, page 65. So justification must include detailed information on the physicochemical characteristics as well as aspects related to toxicokinetic behavior and toxicological hazard. And actually, up until recently, there haven't been a lot of toxicokinetic studies on different forms of TiO2. But TDMA have just completed 5 TK studies on a range of different TiO2s, including E171. And the relative bioavailability is something along the lines of 0.001%. So very, very low bioavailability of TiO2 in general by the oral route. The guidance, the next point, the guidance of an E171 opinion appears to be applied inconsistently. So there seems to be a different threshold for read across to show, you know, that it's not safe. So some studies were weighted in as being highly important. Some studies were weighted as not being so important. And this really comes down to how the nanoscale considerations have been applied to a lot of studies. So in the EFSA opinion, there's about 287 studies where this nanoscaling approach has been applied. And we're concerned whether it was consistently applied, really. So as I've said, the EFSA developed a comprehensive scoring for nanoscale considerations. It isn't actually in the main guidance, it's in the annex. So you have to go and find this, and it takes quite a while to dig it out. We eventually found it, but interestingly, I guess the highest score that you can get, an NSC score, which is 1, requires a very prescriptive preparation and dispersion of the material. And I'm not going to sort of labour the point because it's outlined on this slide. So as I've said, the nanoscale considerations are not specifically included in the guidance, it's in an annex. But it makes a reference to getting actual confirmation of exposure of cells and tissues to nanoparticles or cellular uptake for in vitro studies and to increase the reliability. So because this guidance is so new, actually the sort of type of cellular uptake data that EFSA are now requiring, it's not commonplace. It's not. So we were one of the first industries to do some work at Swansea University looking at cellular uptake of TiO2. And that was after the sort of main request from EFSA had already begun on the extended 1 generation study. So for us in our industry, there was a bit of a mismatch of the alignment and application of the approach. And when we look at the sonication itself, we find it quite difficult. I can see from a scientific interest why you would apply that, but we find it difficult to justify why we would use such high energy to sonicate a material, because this doesn't happen in the food manufacturing sector. So we've gone back after the EFSA opinion to actually ask food manufacturers, do you sonicate TiO2 before you put it into food? And none of them do. So then we asked the question, well, is a consumer ever exposed to a sonicated grade of TiO2 in food? And we don't think that is the case. So, you know, we think that Arguably, it could be contrary to the guidance itself. It's toxicological studies in which the exposure of laboratory animals mimics the consumer exposure to nanoparticles or relevant for risk assessment on point 1 on page 51. But we know from the food manufacturing supply chain, both in Europe and outside of Europe, that this isn't actually the approach taken by the industry when they're preparing foods. So overall, we have a sort of feeling that the nanoscale considerations are not consistent, and that is a particular issue for us. There doesn't appear to be anything specific on E171 with the nanoscale approach, and I think it would help industry. You know, if you're going to apply such weightings in nanoscaling, perhaps it almost has to be done on a bespoke approach for individual materials, because they all have different rates of agglomeration and deglomeration, etc. That was that slide there. New study designs. Now this is this is an area where the industry is very interested. Obviously, if we are going to try and remove the uncertainty around E171 and titanium dioxide in general, the study design is going to be pivotal. So, you know, there may be requirements for additional EFSA guidance. You know, in specific cases, especially when exposure occurs mainly via solid and liquid foods, you know, do you need additional groups with dietary administration, and should this be included in a study design? So you have, you know, conventional feeding studies in food matrices, and then you have gavage studies. So it could double the amount of studies that you actually need. Part of the concern we also have, because the titanium dioxide industry is a global industry, so it's, do you need, and it, in a way, the whole premise of the development of OECD guideline studies has been to harmonize the approach across the globe. But now we see in Europe that there may be this divergence where you have to do specific things in Europe that might not be the case in other parts of the world. So that's a concern. You know, so does that mean we would have to do 2 parallel 90-day oral toxicity studies on E171? You know, and based on the precedent in the opinion, should sonification and dispersion agents be applied in these new studies? So you would have the new type of study with sonication and dispersion, and then you would have a conventional type of study. So it creates ambiguity and uncertainty for the industry. And in a way, we think, you know, if it's confusing to us, and we're in the industry, and other substances will be sort of faced with the same sort of dilemma. What is the most appropriate design for the study? There's a theoretical science, so the guidance has a lot of theoretical science in it, but actually when you talk to the food manufacturing supply chain, they don't do this in the food manufacturing supply chain. So the question may be what's appropriate. So to conclude, I think overall for us, you know, we accept the guidance is there, but there appears to be some inconsistencies in the way it was applied to E171. We look forward in due course as we start to develop the new science, maybe coming back to talk to EFSA and the experts in the regulatory community about what would be the appropriate design, and we would welcome that input. Overall, we found difficulty in applying the guidance for new studies, and I think part of the concern may be, you know, you can have these dispersion and sonication protocols, and they're okay for either in vitro studies or short-term studies. But if you're going to do a subchronic feeding study or subchronic study, like, for example, the extended one generation study, you're not going to be able to sonicate and characterize the material every day for 500 animals in a study. So there needs to be some sort of practical element there. I think overall, clarification in this area could help in the assessment of food additives in the EU and beyond. We are having discussions with regulators outside of Europe, and they are interested in a new approach in Europe, I must say. And you know, TDMA are willing to cooperate with EFSA and stakeholders to sort of improve clarity, you know. And thanks for your attention. And there's more information about TDMA on the webpage. Many thanks.
Thank you very much, David, for presenting your views. We will now start the session on the question and answer, and we will go for the first the three speakers of the second part of this morning. I see in the chat that there is a question for the first two, very similar. It's related to the cost of the study. I know that this is a tricky question, particularly when we have already close to 300 people attending. But as chair, obviously, my obligation is to pass the floor to you. So first to Kat and William, and then Federico, you have also this similar question. So whatever you want to inform, that will be welcome.
Thank you so much, Jose. Yeah, so from a general point of view, what we can say is that the cost is really, you know, associated with the kind of study and the kind of material that you are assessing. So you know that from a toxicological point of view, depending on the nature of the particle that you are assessing, is it a particle which is intended to be used as a nanomaterial, or do you have a nanoscale within the distribution, which is the cause of the toxicological study using the EFSA guidance, makes the difference in the cost. Of course, the cost would be also evaluated and reduced in accordance to the right study and the right evaluation of the guidance. And part of our presentation, you know, we were saying that the challenges that we were facing was to select the adequate CRO, which were well educated in the guidance and well understanding the guidance in order to apply it. So I think that was one of the challenge that we were facing, and starting really from the characterization of the particle you want to test and going further. William, would you like to add something?
Yes, so just to echo what Gad said, there is essentially, it really is the particle, the nature of your particle and what kind of study you need to do. But I would say that you have to be ready to make a certain investment because of the bespoke nature of the whole thing, and that there is methods that need to be kind of developed that are particular for your particle, for your condition. It's not something that can be taken off the shelf. So there is a certain amount of investment that needs to be made into the product.
Thank you, Federico. You have the same question for you. There is additional information you want to provide?
No, as mentioned before, cost and time depends on the composition of the ingredients. So we can range from inorganic to organic, and organic substances have different analytical methods and so on. Of course, it is a process that requires a proper method developments, not only for particle size, but also for dispersion protocols, for the analytical methods, for quantifying the active substances in the different fractions, soluble fraction, particulate, and so on, in order to have a quantitative data. So I think it is a project, so it requires time for sure, but I think that cost could be reduced if an applicant or someone start from the beginning with the let's say, proper and right approaches in order to avoid any loss of time or costs that produce useless data.
Okay, thank you. And we have also a second question specifically for you, Federico.
Okay.
If you can clarify in your presentation, you have something on the micronucleus test.
Yeah, I would just clarify that it was one of the tests that have been applied on a yacht, and I just put an example just to show how to adapt tests when you are facing with nanomaterials. As you can also read in the EFSA opinion, other tests have been applied in order to prove safety. In my presentation, just put an examples in order to demonstrate that if you are working with nanomaterials or let's say nanoscale objects, you should of course have some attentions first of all in order to evaluate stability in test conditions in order to avoid any alterations during tests, and then obtain data that are not useful for a proper risk assessment. The second one is also when you are working with nanomaterials, you are working with the particulates, so it is important that a specific phenomenon that has been observed is not hampered by the inability of particulates to be, let's say, absorbed, but no effects are really due. Also looking at the presence and the internalization of particulates and particles from nanomaterials. So in that case, it's more you have a complete overview, and then you can perform a proper risk assessment. So it was just not focused on micronucleus, but it was mainly focused on the approach, nanospecific approach on toxicological tests.
Thank you, Federico. And David, I have a question to you, because I see no specific questions to you in the chat, so I think that we will have a specific question to you. It's a comment that I would like to see what is your view on this. You mentioned the issue of the need for cooperation between the EU and outside. We have a specific group of regulatory agencies that is led by EFSA that are specifically in the area of food and feed. And we have created a specific working group which is college between US FDA and EFSA. We have already participants from Latin America, from Asia, and obviously from Canada and a lot of European countries. And one of the goals of this group is to further develop the new methodological approaches. So the use of in vitro methods, of in silico approaches, and to try to do this at international level in a way that we are not expecting to, basically setting a guideline or a guidance at OECD takes too much time. And what we want is to accelerate, but in a way that in the regulatory context, you will get internal acceptance of methods or specific elements. Do you feel that this kind of approaches is relevant and will facilitate the possibility for industry to contribute as you want to the safety of products in the food area?
Yeah, thanks, Jose. Yeah, I mean, I think it's the way forward, really. I mean, if there's a new, I mean, I'm a toxicologist, so I'm not going to stand in the development of new approaches. I think it's fundamental to the science, but it's trying to get an approach that, for an industry that's a global industry, we need to understand, what the industry, what the regulators are going to do around the globe. So I think it's a great initiative. We would be happy to sort of participate in that, and even in the discussions, because we are going to have to develop a new science program to address some of the uncertainties on genotoxicity. So we're open to discussion with the regulators. So yeah, I think it's a good approach.
Okay, thank you. And now we have a specific question to you related to the sonication impact. Do you want to answer this?
Yeah, I mean, the sonication itself, I mean, generally speaking, E171 was considered a pigmentary material. So, you know, you wouldn't consider it to be a true nanomaterial. It has a nano tail in it. And we've done some work where you can apply increasing levels of shear energy to get to the primary particle size if you want to. Our question is more, is that relevant to what consumers are exposed to? So, you know, we've talked to various industries that make soups and candies and all sorts of, you know, mayonnaises, all sorts of food. None of them apply sonication. So, although there may be, you know, the tail there, the question is the consumer truly exposed to it? The flip side of that is there have been quite a lot of studies done on E171 in the context of what a consumer is exposed to. So how, you know, in a feeding study or whatever. And we haven't generally seen lots of adverse effects. So I think it's getting a balance really between the conceptual science and what happens in the sort of real world. Even in the EFSA opinion, there is a level of uncertainty about what happens in the food manufacturing base. So we try to get some information on that. We're happy to share that information as far as we can. But yeah, we don't think really sonication is applied.
Okay, thank you. I see also in the chat a comment on the EFSA view. Obviously, this covered the toxicity toxicological assessment, and that will be covered tomorrow because it's an assessment based on a material that obviously have a fraction of nanoparticles according to the definition. And in the presentation tomorrow on the example for the toxicity, obviously we will cover several examples that has been already adopted by the EFSA panels, and one of the examples can refer to some of the elements that David, you have put for the discussion today. So I hope that all of you will join us tomorrow as well, and we can continue the discussion immediately after that. We have.
I may just have a quick comment, you know, regarding the cost, because we were giving a first answer. We were giving to the team, you know, within our presentation, the cost for the 4 studies at least that we are performing. So if, you know, people who are attending the call would like to have more information about the cost, they can refer to our presentation later.
Thank you. And I think that for the cost, the best is that you just contact the laboratories that are ready to do that. And that's something that is a private discussion that EFSA do not need to be involved. So one additional element is that some of the, and it's indirectly linked to the cost because obviously the cost depends also on the demand. One of the elements that I think is very important for EFSA, but also for you to know, is that we are fully aligned the discussion of the guidance in this area with ECA, with the European Chemicals Agency. So if you have seen some of the elements of the new specific adaptations of the ECA guidances for the risk assessment of nanoforms in food, they have considered several of the elements that we have in the EFSA guidance. Obviously, we were mentioning before international coherence, but obviously internal in the EU is also essential. With that, we can go back to the questions that we have before. So thank you very much for the 4 of you for your excellent presentations. We will continue the discussion with the other experts from the working group.
Thank you so much.
Thank you.
Thank you so much. Thank you.
So we have still 5 minutes, so let's try to have some specific questions. A centralized mechanism for submission, specifically in the area of nanomaterial. This is more for the decision for the Commission. You know that so what we are talking today is on conventional materials that have a fraction of nanoparticles. So there is no expectation for EFSA or any other agency to have this. For chemicals covered by under the REACH regulation, the REACH regulation was modified to have the need to address in the registration of the substances, the specific registration for nanoforms. And as you know, there is an EU observatory that is handled by ECA that may include also elements related to that. But I want to use this question to again clarify the fact that a material has a fraction of nanoparticles are from the risk assessment perspective. So what is relevant for EFSA require this nano-specific consideration does not mean that the material is nanomaterial or that meets or do not meet legal requirements. Those are specific in the different legislations. And as Takis was mentioning, in the food area, there is a specific definition in the Novel Food Regulation. Can we move to the next question? Is the appraisal route for the dissolution and GAT? That's the guidance provide pH recommendation for infants. And I will pass the floor to Agnes for answering this question. Agnes, please.
Yeah, thank you. So the short answer to this question, does this guidance provide PA recommendations for dissolution testing for infants, is no, but there may be an annex to provide some guidance here. So we're talking here mainly about infants, very young infants, let's say infants younger than 16 weeks of age, where the pH in the stomach may not go as low as pH 3. And for the cases where there may be a fast dissolution at pH 3, but not at pH 5, which is more relevant for the stomach pH of such young infants, where there is a buffering effect of the milk, and also those infants are fed on a very regular basis, so there is no time for the pH in the stomach to decrease to as low as pH 3. So the answer is no, there is now no guidance in information on the guidance for your very young infants, but maybe in the future. Thank you.
Yeah. And thank you, Agnes, for the response. And obviously, this response will trigger by when. I can answer that part. So we are now, we have already discussed with the scientific committee that the best way to address this, and also to provide more clarity, is not that we are going to modify the guidance, but to provide a specific annex with recommendations both for the applicants, third parties, but also for the EFSA panels for on how to do the interpretation of the substances that have different dissolution rates at different pHs. And the expectation is to be able to provide this annex already this year. We will try to have a large internal consultation, obviously with all the panels, but also with the Nano Network that include all organizations in the member states, as well as a lot of observers. And we will try to do our best to have this clarification already published this year. With this, I think that we are at the end of the first session for today. We have more than 250 participants, 280, 90 in some cases. So I want to thank all the speakers for today, as well as my colleagues, both for the scientific part and the technical part, and the members of the work of the working group that has addressed the different questions. To just thank you. And as you know, we will have a new discussion tomorrow with a focus on the scientific guidance. This afternoon, we'll be busy trying to go through the chat and trying to get additional questions that will be solved tomorrow. Please remember that you have a different link for tomorrow. And I want to thanks also Claudia, our head of unit, for the support that we have received, and all the colleagues that are supporting the progress for this. It's a challenge to have this large number of participants for an online meeting. Thank you very much. Enjoy your lunch. We will see again tomorrow.
See you tomorrow. Thank you.
Thanks a lot. See you tomorrow. Thanks, Jose.
Bye-bye.
Bye.